we should be live now.
Yep, I guess so.
Let's just wait for a few people to join us.
So we are gonna speak in English, right?
Yeah.
Okay.
I think that just makes things simpler at the terminology-wise.
Okay. Yeah, just it would be nice to give a hint at the beginning line, just for the people, just to let them know that we are speaking English.
Yeah.
Okay.
Once we have a few more viewers.
Sure.
All right, welcome everyone. I don't know if you've been formally introduced to me or to Osama. My name is Ahmed. This is the first time I run my own stream. I have been invited before, and I've had several of these spaces on Twitter, but never really my own live stream. So this is new to me. If I'm trying to figure things out, please bear with me. Osama, do you want to introduce yourself real quick?
Yeah, sure. Thank you, Ahmed, for having me for this. Let's say for this live. It's the first time, I guess, to be in a live with you. So I'm really happy that it's your first live, and I'm your commentary, your guest over this. It's been arranged in the last moment, so yeah, we don't know how it's gonna go, but let's see. Let's do it. I believe more in learning by doing. So let's do it.
Exactly. So. Really, what led me to think about this is the newly released KTransformers optimized version. It's v 0.3 basically, and they did some stuff that allows you to run the DeepSeek R-1 full model, the 671 billion parameters model, on pretty much fully offloaded to the CPU, except maybe for one. For just the active parameters, which requires 24 gigabytes of VRAM. A lot of people have already done live streams and showcased trying to get this model running with llama.cpp, but this is the first time someone tries to my knowledge, this is the first time someone tries to showcase this new inference engine. If anyone is curious about inference engines, just recently I have written a blog post on inference engines. I titled it, I gave it the title, "Stop Wasting Your Multi-GPU Setups with llama.cpp," and in it I really go to some kind of depth about what inference engines are and the difference between some of them that are out there and popular. So give this one a read. It's available on ahmedosman.com if you're curious about this. Besides that, how did I come to know about this whole thing? It was pretty much the KTransformers team. They posted it on Reddit, and I decided to give it a go. So what we're going to be doing today is building this inference engine, getting it to run on my AI server. Also, just for your information, in case you're new to my profile or anything, it will be running on this thing. It's what I call my AI server.
Looks really pretty cool. How
Thank
long
you.
it took you to just build up everything and collect it and integrate it, configure it, and so on?
So I started the mission back in March last year. So it was March last year that I started getting together the parts. I didn't have it up and running until July, and back then it was only 8 GPUs. I've had many accidents with it. There was a lot of small stupid things that I had to figure out, pretty much these things are running on PCI risers, right?
Yeah.
Or razors, and And for these things to work without erroring out and crashing the entire system, you actually need retimers and redrivers. You can't just use the cheap Chinese, Luby cables that everyone uses. These things will bring down the performance. You have to pretty much either change to PCIe 3 or deal with the enormous amount of errors that PCIe throws at you. I started with only 8 GPUs, and then I added 6 more later. And the plan was to actually add 4 more GPUs, but I ended up putting them in different nodes. So I have several clusters around. Like I have a cluster with multiple nodes around.
Exactly.
That. But this is the
This
biggest
is
one that I have.
it's a totally independent cluster over there in your house.
Exactly. So we will be running this whole thing on this AI server. It has 14 RTX 3090s. Each is 24 gigabytes of VRAM. That's pretty much 336 gigabytes.
Nice.
And it has 512 gigabytes of RAM. It's DDR4, so it's not like the bandwidth is not as good as DDR5, but it will do. So
yeah, it will do the job everywhere. Like
yeah, it will do the job exactly. And first thing we need to do is actually figure out how to get KTransformers to work.
I have one thing in ahead, please, Ahmed. If you just allow me, please. Like
yeah, absolutely.
You have thrown a lot of terminologies over here regarding like LLM, DeepSeek, GPUs, and so on. So would you like to, let's say, clarify some terminologies before even we like start getting deeper in the stuff over here?
Yeah, please. Let's do that.
So yeah, let's talk about a little bit about what's the llama, what's what's VLM, why you are even motivated to do that, what that means that to like make a model is being offloaded or by CPU or something like that. What the effect of this on the whole process and why we need something like
that. Okay, so an inference engine is pretty much a piece of software that knows how to take the input that us human beings give to any of those AIs, right? To any of those models, and it's able to make that go through all the pipelines that the model is built, is made of, and then it's also able to take whatever output is being sent by the model and then show it to you in a human readable form, right? So that's in short. You have a lot of inference engines out there. You have llama.cpp, which is the most used one. Llama is a wrapper around llama.cpp, and it's pretty good if you're running one GPU or running one GPU and want to do some kind of CPU offloading. CPU offloading means that the model layers are offloaded to the RAM of your system rather than to the VRAM, right? Rather than to the video memory that you have on your GPUs. Nice. And then it comes down to like bandwidth and latency, and you have, it becomes a lot slower if you're trying to offload your models on the CPU. But it's a cost benefit thing right now for a model that is 671 billion parameters. I mean, I'm downloading the N4, I downloaded the Q4 quantization in the GGUF format, and it's 400 gigabytes, right?
Okay.
So that's huge, and you cannot. I don't think that a model like that can be fully offloaded unless you have like a cluster of H100s, right? Or H200s. Yeah. So for I'm not saying I'm a poor man, like I don't have I don't have like I'm lucky enough to not be called poor GPU likewise, but also I don't have enough GPUs to run this model at at what's called like BF32, like at the full weight, pretty much. So
Totally. Like there are huge research groups over there trying to do that on a small, or let's say little numbers of GPUs units, and some people try to do that on the edge. So there are really like a huge push in the total world to do like just to deploy that on a little bit less numbers of units than what's actually needed over here. But let's get back one more step back for why we llama and the rubber or llama is not like what is being famous about them. They are just working on a single GPU. So is that right? Like we cannot parallelize them over multiple GPUs?
So you cannot use, well, you can split over multiple GPUs, right?
Okay.
That's for sure. Olama does a bad job at the calculations of how to split layers between several GPUs. So it doesn't work out of the box greatly. But llama.cpp, it does if you know how to configure it with the arguments it allows to configure, splits. Really, if you think about it, llama.cpp is just one inference engine that supports a wide variety of hardware and allows you to run your models, right? Xllama does the same. All these VLLM does the same, right? All of these inference engines, they have the same goal. It's just what are they optimized for is the question that they pose, and they are optimized for different things, right? Xllama allows for tensor parallelism, and it's great. Tensor parallelism means splitting the different layers across many GPUs so that when you're doing calculations, when you're doing matrix calculations over these GPUs, you can be running several layers on different GPUs and running the same layers for different requests and aggregating them at the very end. So it allows for computation to happen at an exponentially faster rate, right? llama.cpp doesn't allow for that. llama.cpp is telling you, no, you have to wait until I'm done, and then we will take the next request, right?
Okay.
This part of the GPU is busy right now. We can't do this until the next, until we're done with this request. Then this next upcoming request will be handled. So it's kind of like, the trade-offs are really, llama.cpp has a huge community. It supports the most famous quantization out there, and it allows you to offload to the CPU alongside to your GPU. So it's people that have showcased running this model online have been using llama.cpp, and it's because you have a bunch of GPUs. It can offload some of them to the GPU and then offload the rest to the CPU. And there's I don't know if you're familiar with Unsloth, but he released dynamic quantization in GCUF for this model, and that's what most people have been using. It's basically 200 gigabytes for the 1.5, and it works great, honestly. Like for how small and how compressed the weights have become, it works pretty well. And I might try them out later, but for today, I just want to focus on KTransformers. But I'm with you. If you have any more questions, if I'm not clear about, if my answers are not clear, please go ahead and follow up. That's for sure.
That was really nice. You covered the main idea behind why this inference engine is not capable to parallelize or do actual tensor parallelism over multiple GPUs over there. But you have mentioned one thing, and this will be my last question before we dig deeper in the application today. You mentioned something about quantization. So that's for high-level software development. For the people that working on the last layer of software developing, just integrating the output model and or the output from some models with some application interface and so on, they are not much aware about the quantization, what that means, and what's the importance of this. And does it really matter to quantize a model into a low bit precision or not?
Do you want to take this question yourself? Because I think you can answer this one. While I'm drinking some of my water. Hey, it's my first stream. I'm a little anxious, so you got to cut me some time.
I'm trying just to go easy with that. It's like quantization.
No, I'm actually glad you're here, because I honestly would be just umming the entire stream. So I'm very happy that I've got you on my side here, asking questions and making this more interactive. So, but I think you can take care of this question. You know how to answer that one.
Okay. Yeah, but the point is, you have shared something. Let me just see what exactly you are sharing.
No, this isn't any relevant. I was actually going to bring up one articles, but
okay.
for
So
the other one.
quantization, like from another point of view, like quantization has so many perspectives when we are talking about the quantization in deep learning models, especially transformers, which usually they have like like multiple heads of attentions over there. So drive the whole parameters with the whole heads as like the original model as per design, and try to optimize this and deploy and so on. It's sometimes occupy a lot of, like, let's say, memory and so on during the running, during the data transmission, during the requests receiving, sending, and so on. So we try to optimize the whole model information into some low bit precision. And I'm just speaking like very high level overview over here without like going deeper in some technicalities. And yeah, the most sufficient, like the goal to go into like 4, 5, 6-bit models without affecting the precision or the accuracy, because like, you know, it's a compromise and it's a trade-off. Like when you go down for a low level of quantization, you lose some information over there, some representation for the information. So sometimes that affect really highly on the performance of the model. Yet it's really necessary to go deeper and try to understand what that quantization means and try to do it, because at the end you try to run your model in very limited space and memory, and you try just to shrink the size of the parameters and the, let's say, the data inside the model, and make the model capable to perform under very low bit precision representation for your data. That's what I can say about like the quantization without going into like mathematical terminologies or some like deep stuff. Will not like be sufficient, or not will help us today. But I mean, like, quantization is a really nice topic, and what I see over here that you have mentioned that the llama and the X llama v2, it's the best for quantized model, right?
Yeah, pretty much X-Llama if you're doing only GPU offloading, meaning that you're not using your CPU or your system RAM at all while you're trying to load a model and get it to work. So X-Llama is the way to go. VLLM if you're trying to use the full weights of the model unquantized, then that's the way to go. I wrote this maybe back in October, and it was on quantization, mixed precision, weights, and activation. And I think you touched a little bit on that, but do you want to maybe talk a little bit about activation weights and the difference between the weights and activation when it comes to quantizing a model? Just a high level overview.
Okay, so yeah, what you are, I'm reading over here, like, okay, this mixed quantization, yes, precision over here that we can use it. This, for example, like, you mean like a model 4-bit weights, 16-bit activation quantization, which lower and storage competition of weights leading into reduction in storage. Yeah. That's, imagine you're running weights accuracy. Given my limit resources. Okay, so yeah, we are talking about, like, let's say the weights, the 4-bit weights, and the quantization weights. Let me just check something before I start talk about it, so we'll not like use.
Do you want to share a screen? Or
I don't know if I can share. Okay, let me try.
Okay.
Let's. Because I'm running this on the iPad here, I'm just working on my laptop.
Take your time.
Yeah. 1 minute. Okay, yeah, that's fine. I don't know, StreamYard, sometimes it works, doesn't work very well, so I don't know why. No, not privates. Yeah, that's my lovely one. Okay, let me share. Present, right? Yeah.
Yeah.
Share screen. Window. Entire screen. It's not. You see it?
Okay. I'm gonna add it to stage.
Yeah, it's coming.
Yep. It's on now.
Okay, so Hugging Face, my favorite guy. Like,
Our favorite guy. Excuse me.
I highly believe if like Hugging Face like offer me something or some job, maybe I would take it without any salary. Like really, I like those guys.
Wow.
I really
Okay.
like those dudes. Yeah,
That's
I
passion
like
right there, man.
Yeah, truly. So the thing is, we have two things we need to focus on during the quantization. We have the parameters, which it's called the weight, and we have like the input output and the like the what's happening, and some other parameters or some other values inside the architecture, which is called the activation or the activation quantization. So usually when you try to develop this on like a high level on your laptop or your like PC, usually we go into like precision like 32 with the type float or like integer like 8, it's the best. But let's talk about like as you have mentioned or you had mentioned at the beginning of the stream, like we are talking about hundreds, sometimes thousands of parameters, millions of parameters. So multiply this in the occupied memory that it's needed to process all these spaces. That's all this volume of the data under the precision of float or integer 32. So when you are like running like one single layer with like 9 inputs neuron, 1 or 2 output neurons for classification or binary classification task, you will not notice any problem if you do a quantization. But let's like start by a deep architecture. Let's even go not for the transformer. Let's go for something special like in CNN, like something like VGG or like AlexNet or those architecture that they have really huge number of layers, and you have to concatenate those layers and multiply those layers and attach them and increase the number
And
of
ultimately,
parameters.
just to make people aware, ultimately you're talking here about deep learning neural networks, right? Which Transformers is one of.
Is one of them, exactly.
Yeah. So
Yeah.
he's talking about this similar kind of stuff. It's just different kind of a model, but it works pretty much like in theory, the fundamentals are the same.
Exactly. Like if we like that's a nice hint. If you let's transform architecture. Let's focus
I just
more
want
on
to
the
make sure that people don't get like scared away by mentioning all these acronyms without.
Yeah. Without even drifting like into something like
Yeah.
So let's for example talk about something like that. I'm just waiting. I'm using my old Mac, my dude. We have been together like since 2016, so I cannot like let it go. Like
Yeah, Astro,
we will go together. Like so,
yeah,
it's a little bit
exactly.
slow. Let's a bit slow. So yeah, guys, yeah, don't just embarrass him. Like even I have a name for it. Well, like this laptop and I have been through a lot, so it's really kind of like attached to it. So for example, like let's talk about the transformer better. So we have like the input part of the transformer, which it's been known as encoder over here. And yeah, this is like, let's say, a lateral view of the transformer. Actually, this is a very, like, it doesn't cover all the component of the architecture itself. Why I'm saying that? Because like, let's explain a little bit how it works with the words or with the text particularly, not any other sort of input data. Basically, you have like word embeddings. Like what that means. For each word, we have a certain numerical representation for these words. Okay, and those words, they are like stacked in one column or one matrix, and we pass it into the first input layer. And the first input layer, sometimes it's a dense layer that produces three values, which they are the key value and what the Q, what it stands for. Key, K, V, and Q. Q stand for what? I forget it. I'm sorry. But it's a QKV. That's the most famous like representation for the output of the dense. Then we use the dot product of the key and the Q, and then we use the
Query
value.
attention.
Sorry?
Query attention.
The query, exactly. Yeah, forget that. The query attention, exactly. So the query key and value, so we get the dot product and so the first part is a dense layer. Then we have like the product, the net product between the key and the Q. So this is like a vector, and you know, when you multiply two vectors together, if the two vectors are in the same direction, so we have a very long vector. But if they are like opposite directions, so we have a short vector. So sometimes the output is very long. I'm talking here why I'm explaining that, just to explain how many parameters inside the architecture itself, and then just to lead the audience into why it's important to quantize all of this, because it's really hard to run like millions of parameters over this architecture. I'll try to like wrap this very, very fast. So we have like, so this is the second stage. We have the vector product, net product for the key and Q, and then we have the softmax, which take the Q, key, and V. So we have the third part with the parameters from the softmax. And don't forget the position encoder that already exists in the middle to find the positions of the words. And this is the encoded part. So imagine you are, this is for one single word.
This is just one step.
One single word embedding and one single head. So imagine you have like a full text, and imagine that you are passing with multiple heads to increase the combination between the product between the key, Q, and values, and the dense product, and so on. And all of this is running under the precision of float 32, for example. So, and we want to deploy this. We want to run and train and get the output and then run an inference without even going through the math, just by imagining. This will be huge if we stay at this bit precision. So we have to go down. We have to lower the bit precision, and this operation called the quantization. So now we have two parts of quantization: the input, the word embeddings, and the output, the word embeddings also, or the text that output. This is the activation one. But the weight quantized is the parameter inside, the one I explained it, the output of the dense layer, the vector to products, and so on. So, and this is a very tricky part, because sometimes you can quantize some part of the architecture into, for example, 4-bit precision, and it doesn't matter. It doesn't matter. It doesn't affect. And sometimes you cannot even go below 16. For example, like the output of the dense layer sometimes is very, very precise, and you need it. You need it. You want to keep it. So yeah, that's, I don't want to go deeper in the quantization. Is a very, very huge topic, but let's say this is the importance of it.
So yeah, let's just do a quick recap. And by the way, you did a great job, like just trying to like break it down into simpler terms. But I think we might need like a whole entire series for quantization alone. But in simpler words, you have both the activation, which are more tied to your input that you're submitting, and then you have the weights themselves, which is the total amount of data that you have in a model. And when you're doing quantization, you can quantize one or the other, or you can quantize both, right? You can help. And when you do that, you're pretty much making them breaking down the amount of data into small, like taking away data that might be less important, or like bring you more accurate data at the very end of the layers, right?
Yeah. Yep.
Yeah. So you're pretty much trying to take away from the density of the model, how huge it it computes over a certain input, and make it smaller. And when you do that, you allow it to fit into a smaller amount of RAM, into a smaller amount of memory, which allows somebody like me to run 14 3090s instead of 14 H200s. So it's pretty much compression, but for
yes.
deep learning neural networks, and it makes things, and there are multiple parts to it. The most important thing that we know is that it ultimately it makes the model smaller, it makes it take less space, and it makes it probably take less time to do a calculation.
Exactly. I like the word that you use. I truly like the word. It's a compression. At the end, it's a compression process. Yes, it's a compression procedure. Yes.
Yep, exactly. So that's just to summarize quantization. I on my blog, part 2 of my serving AI from the basement, I have written a few paragraphs about quantization. I think they are good in addition to what we just said, to like just give people some idea. But there's a lot more to be said about quantization.
Yeah,
now
true.
let's go back to KTransformers, and we actually have a bunch of questions, and
really?
we got one question.
I forgot. Honestly, I forgot that you are in live. Like I'm just.
No, we're just. This is just a conversation, right? Like we're honestly just hanging out here with other people watching us. Hopefully, we give them some value, but this is just a conversation. We're just trying to have fun. Pretty much, I haven't ran KTransformers. I haven't ran DeepSeek R-1 at all on my setup, and I'm just gonna be like standing in front of errors in a few minutes here, just being like, what the hell is going on? How can I do this? And it would be just me, myself, and I with you doing the same thing, trying to figure out how to get this thing to work. So,
true,
guys, this might take some time. So, we got one question. If this is recorded, yes, this is recorded. The question was in Arabic. Yes, that's for sure. It would be available on my profile. We had another question about would you change the quantization depending on how you fine-tune it? Example given when using QLoRa. What do you think?
What do you mean fine-tuning? Like fine-tune the train model, a pre-trained model, or you train a model?
No, I think what he's trying to say is, let's say he's trying to fine-tune a model with QLoRa, right? And he's wondering, would a certain quantization work better? I think that's what he's trying to ask here. Would a certain quantization work better than another? So if you can clarify your question, I don't think it matters, but if you can clarify your question, like send us a follow up with it. Yeah, he said exactly. So I don't think it matters.
No, I agree. Yeah.
It doesn't matter. Ultimately, you're going to be fine tuning a model that has certain weights and a certain quantization, and it's a shot of luck. It's a luck shot whether it's going to work out or not, because again, it depends on how a model reacts to being quantized. That's what I'm trying to say here. Yeah, some of them lose more accuracy and precision than others.
But LoRa and even LoRa, they are famous by not like the minimal precision loss. Actually, like they are famous by that. But you have to benchmark it. I would say it.
Okay, and I wasn't talking about QLoRa and LoRa. I was talking about quantization of the model itself into like 2 bits, 1.5 bit, etc. So I think it was.
Like it's a tricky part. Like this is really tricky to reach into 1.5 bit. Yeah, that's
really, you have to benchmark it.
Yeah. I have tried that and I failed. So yeah,
I agree with Sam on this. You have to benchmark it.
I speak on experience. Like it's not easy.
Dude, we should get together and do some fine tuning. Like honestly, some fine tuning. Like we should. Yeah. Like recently, I haven't been doing much with my AI server because DeepSeek's API was so cheap. It honestly became cheaper to just run the API than to, except for my infamous tweet like Trump.com website, which I encourage everyone to go take a look at. And it's hosted on premises. It's actually hosted on this thing right here. It's using an 8 GB, 8 gigabytes of VRAM of 3070 GPU.
Wow.
So nice. Yeah, the LLM, the embedding, the re-ranking, and spacing NLP stuff, all done on 1 GPU in under 8 gigabytes. I was very proud of that actually, and it's a It,
Sure.
it was a very interesting project. Anyway, let's go back. Let's get back to KTransformers and
KTransformers, yeah.
and what we're going to be trying to do right now is get this thing to work, and then try to load the model with it. They have written some good information here, but unfortunately, the V0.3, they haven't updated the documentation about how to build that. So this is going to be our adventure here, actually trying to get this most recent version to build on our own, and then load up the model with it. They have documentation on how to get the model running. Do you have a DeepSeek R1 V3, like either R1 or V3 of the model of the most recent DeepSeek models? And they ran them in the Q4 K medium quantization, which translates pretty much to an N4. So I decided to stick with that. It's 404 gigabytes, 404. Funny enough, 404 gigabytes of like 5 sides, safe sensors, and they have basic instructions on how to run it on a single slot, single socket CPU platform, and let's first try to actually get this thing building. How about that?
Okay. I cannot find that GitHub, that repo for KTransformer.
Okay. I'm gonna send it to you right away.
Yeah, please.
Yeah, because I might need your help to actually troubleshoot this thing as we go.
Let's try.
And everyone, we haven't prepped for this. I'm just saying this because this might end up taking hours. So, like,
Yeah.
just have your lunch, do whatever as we have almost 200 people watching us live. So
200.
yeah.
Wow. Wow. I feel like bunch of dudes over there, like they're just
like, what are we doing here? I think what we're trying to do is to show that this whole job is, it's full of tiny little things that, like, nonsense, like, that annoy all of us, and everyone
Totally.
thinks that, oh, it's straightforward. No, it's not straightforward. I sit down and I struggle with documentations trying to get things to work.
Totally, yeah.
So the quick start here is to make sure that you have code up, blah blah blah. So let's make sure that I actually have all of this stuff.
I found it. Okay.
I believe I have all of these packages. Yep, I already have them. And no, I don't use Conda. Please do not use Conda. Everyone use UV. If you're out here, use UV. Don't have UV installed on this machine? Oh man, okay. I'm not on this one, so I'm gonna get that one installed real quick. UV is a package manager for Python. I don't know if you're familiar with it or not, Osama.
Yeah.
But it's the newest kid around the block. It's pretty cool, and it's written in Rust, and it makes me feel like I wasn't alive while using all of these other stupid libraries out there.
Yeah, it runs over like multiple operating systems smoothly without any problem. And
yeah, exactly.
Yep.
Okay. Yep.
CPU feature. Okay.
I have a lot of weird directories, but I'm gonna keep it intact. Actually, no. Let's just do this on its own. Make things simpler. Make a directory. Okay. And Python 3.11 is what they recommend. course. Yeah, right. 3.11. It's going to point to that. Perfect. From here, let's do this. They're recommending we install these libraries. Okay, of course. UV dev add installed, and I made a. Yep, here we go, and it's gonna install a bunch of things for us real quick.
They have really nice documentation.
Yeah, no, honestly, I was using originally I used to use Web, and then I moved to Poetry, and recently I pretty much transitioned all my projects into UV. It's so good to use. Yeah, it's so good and so easy to use, and their build steps are easy. Using them on Docker is so like such a breath of fresh air. It's you run this command, like the curl command to install UV, and then it's installed on the entire system, and then UV specify which Python version, and you don't have to worry. Like I used to have to worry about installing Python and building it from source. I don't do that anymore. That's too much work that I don't need to do.
Yeah, true.
No, like I had an entire Obsidian notebook. Like it's funny. Actually, I'm gonna try to bring it up real quick. I might be sharing too much, but it doesn't matter.
Yeah, who can like catch up? It's okay. You cannot can drop a question. So
yeah, no, I had a bunch. Like this entire notebook is on building Python and
building Python. Okay.
Building Python from source and like all the. Yeah, I know. I'm hardcore about my Python, or at least I used to be before UV. So I'm not anymore.
Python 3.12-Ahmed version.
Yeah, exactly. Like, which parts are you trying to combine with?
That's nice.
I'm trying to get all the add-ons. WebAssembly, yes. Profiling, yes, please. Generate those GMO files for me everywhere. Yes.
But it's awesome. If it works, it works. So it's awesome.
No, I broke an entire Ubuntu system because it replaced the user ban once, and I had to go figure out all the links that were pointing to the old version. And I mean, I updated the entirety of the Python like dependencies of the entire Ubuntu distribution installation that they had back then, and I were like, oh my god,
what?
Yeah, no, like it was very, yeah. Look at this. I know this is off topic, but like pretty much it was pointing. Okay, so I need to link all of these things, and I even documented to point to the newer version on my operating system. It was a lot of headache, but I learned a lot. I like to do these deep dives into Linux and dependencies and how all of that stuff works. It makes me a better programmer.
Yeah.
And it gives me a lot of headaches. So
sure.
That too.
But
all right. Yeah, go ahead.
No, I wanted to comment on something you have said. Like from the other side, like integrating and configure the binaries for yourself as per your needs is something really important to know, at least.
Yeah, no, that's for sure. I mean, there's a lot of small, stupid things about how building and compiling your software and how linking them correctly. But once you have it figured out, it helps you a lot with seeing all these mingled interdependencies between software that seem like scary stuff, but it really ain't. It's just you just need to understand the fundamentals behind it.
That's what I always used to say. It's all about the fundamentals behind it. Exactly. Yes, totally agree.
Yeah. Okay.
And I see something here over the GitHub, Ahmed, like the brief injection tutorial. You want to I don't know what do you think about it? To go first, talk about it, and until like you finish the figuring and configuration.
Do you want me to? Do you want to share your screen and do that?
I don't know. I'm just asking. Like what do you think? Is it important right now to talk about it at the beginning, or just you go further and like we go through the documentation as the
I think we should go like through the documentation as we go about building and getting this thing to run, because
Okay.
I'm trying to give an authentic experience of how to get this thing up and running, so people can hang on with us while we're trying to figure it out. I don't know if you have if you want to go about it differently, I'm down. But that was my original thought.
Let's stick with that. Yeah.
Yeah.
It's okay. It's okay.
Okay. Yeah, we are gonna download source code and compile. These are too easy. I don't like to use Docker images except for my self-hosted stuff. So if you're, I for software like this, I like to play with the source. They also have a pre-packaged version of their library, but this is the one that I'm interested in actually.
Okay.
And let's do this. How can I force this? One second. Alright, this might actually be a little annoying. You see, this file here, gmon out. This is from actually building my own Python. This is the profiling of the Python runs, and part of my misery is that I have a bunch of these files everywhere. Like I even have a Gumon clean file, like alias that deletes them for me.
That's cool, man. I love it.
No, but whatever.
I really love it. Okay. It's been a while since I've seen something funny about compiling some.
Yeah, I know.
But it's cool. It's cool.
Dude, I just added you. Or the username. All right, so very good. Got it. And which one were we looking at? So they have some modules apparently. They have Vibind 11 and they have llama.cpp. Okay, I'm not surprised about that. I assume that they would be using some kind of clone or a fork of llama.cpp.
No, they haven't.
I think they are just they pretty much are referencing the llama.cpp. Of course, they are not just using the most recent
one.
commit. They're using a specific commit in there. It's supposed to be like this option if you want to run this. No, not. But maybe what I want to do, I actually want to support. I want to see what exactly does it do, because I don't want to turn something that set environment, this local chat. Okay, cool. But actually, this is going to be a problem because they're using so I need to do, because we're using UV, so UV at web, and that way we can actually. No, I didn't. Maybe this is annoying because that's not what I'm trying to do. which Python 11. So here. Let's okay. Doesn't match there. What?
What's the problem?
Yeah, it's not matching the virtual environment for some reason.
That you have right now, yeah.
It has two. Okay. Why is it creating a new one?
Okay.
Okay. Already done that before. Nope. I need to figure this out. 1 second.
Yeah, sure.
Actually, okay. Okay. I have to specify. I think this has something to do with sourcing, maybe UV. I don't know. I will figure this out later. No solution found when solving them. What?
Package registry, so you suppose like you had this exporting or
That's interesting. Okay. I think that I actually had, just because I had Bison 3.11 on this machine already, so I'm just gonna use that. Let's ignore UV. I've been trying to get everything to work with UV or something, but it should work. We will need to redo this, but it's gonna take longer time now because we're gonna be using license 3. We're gonna be using the bed version of it. So actually, I had all of them cached, so that's good. Doesn't have to do anything. It's gonna be a little faster.
That's basically everything they've mentioned.
Yeah, and after this, we just need to run their installed.
Okay.
And while that's running, we are gonna run this. That's it. And it's building. Lovely. Yeah, wheel setup tools, blah, blah, blah. Try again. You know, one of those things that annoy me so much about Python as an environment. Let's figure this out first, and then we get back to that. So many things annoy me about Python.
Python is annoying by design, so we cannot complain.
That's true. Fair enough. Fair enough. Okay. Standard error. Right, and that's where we find our nearest GPT-alike LLM and ask it, what does that mean?
Okay.
Let's see if DeepSeek is going to be good to us.
They have mentioned here that you need the GCC and C++ CMake, and this is like essential.
Yeah, and I believe I have all of that installed.
I believe so, yeah. So
I've already ran this command before.
the export in the environment.
I'm just wondering if I actually don't have this, and so let me do a quick. Give me 1 second. See if I can get this. I'm gonna add these quickly to. Let's see if this is gonna make any difference. Don't break my heart like that. Okay, so well, I know for sure now that we have a problem with these things.
Yep.
No, but it's actually I still haven't coded this thing. I have coded, that's for sure.
Yeah. You know, sometimes I always check the environment variables before I start doing anything, just to be sure that everything is added over there, the right environment variables that I want to use it.
Yeah, and the thing is,
oh, you have so many versions.
Yeah, no, but also like ultimately.
They mentioned that they need 12.1 or higher. So if your code is 12, the one yep.
No, I think we're good. And the thing is, like, some of them are pretty much pointing towards things, but here's why I'm annoyed, actually. It's pointing towards etc. alternatives code. So, okay, which is pointing back. That's funny. Which is pointing back to user local Coda. So it's pointing towards the right thing. It's pointing toward the 12.8, which is in this directory here in user local. So this one isn't the problem. I think the problem is going to be the lib64. So I don't see. So it's supposed to be local. And here, one of the environment variables that you have is this lib64. I don't think I have lib64. I don't see it. It's not here. So this might be the thing we need to actually get to work. Oh man, I did this a long time ago. And that's right. Success. Okay, thank you for that. Like, you can't tell me cannot write something and then tell me success. That's just widget people or wget people. Please get it together and actually fix this. Oh, I know why, by the way. It's because we are sitting in a forbidden directory. So we were sitting. We were in the user local coda, and the user I'm running right now is not a system admin. It's not root. So ultimately, it was like I cannot write you here. But then telling me it's success is like it's not telling me enough. Like I had to think about it for a second. Then we're gonna. Please, everyone, if I'm typing my password, do not lock in case I type it in the wrong spot. So.
Just don't tell anyone.
Yeah, just don't tell anyone. You know, I'm always worried that I'm going to share something on the screen. Like in November, I went on the Ask Developer podcast with Ahmed Sharif, and I was saying, okay, like, let me not show this, and it was the continued configuration. It had all the API keys for all my instances of LLMs. And the thing is, I have exposed them, some of them online for like different reasons. I had to go back and like change everything. And it was like, I was so careful, so careful for multiple times. I was able to actually like not show anything, and then suddenly it just the entirety of my API keys were available to people.
Yeah, that's the pain. Like when you expose something, you have to get back and change it, and just be sure about like monitoring your system for a while. Someone just tried to do something over there.
Yep. I think people were nice enough. Nobody tried to do anything.
Yeah, we are all doing this. So what goes around comes around. If you do it for someone will come and do it for you later. So yeah, nobody wants that.
Exactly.
I'm just searching if there is any conflict between KTransformer and multi GPU communication over here.
So KTransformers really isn't made for. I mean, they support in some cases multiple GPU offloading, but they're mainly for CPU offloading. Like that's why part of their submodules is llama.cpp. But what makes them an interesting case, and just because we installed something that is definitely system dependent, I want to restart this machine real quick because I think Coda likes to have system restarts. So I'm going to do that real quick while we're talking.
Sure.
And that should be back online soon. But in their documentation, basically with llama.cpp, and again, this is the same model, right? And this is why I found this very intriguing to actually try and go online live streaming about it. It's the time to first token. same model, same everything, right? But
Yeah.
the pre-fill speed up was almost 10 times faster. That allowed them for like the time to first token to go down from 53 on the same exact quantization on llama.cpp, on same setup and everything, to 6 seconds for 500 tokens. That's huge.
Sure.
That's quite the optimization, right?
Sure.
I
Sure.
mean, look, you can look at the numbers, right? Went from 53 seconds for 500 tokens when you talk about time to first token to 6 seconds. The pre-fill speed, 97 tokens per second from 10.3 tokens per second. The generation almost tripled, right? From 4.51 to 13.69. So these were quite some optimizations made. Um, I know for a fact that the pre-fill speed isn't gonna increase that much on my platform, on the CPU and the RAMs that I have. Um, it's more for DDR5 setups that will benefit from that, specifically um, platforms or AMD CPUs that support the Intel AXM 524 instruction set. Um, my the motherboard and the CPU that I have do not support that instruction set, so I'm not gonna get that optimization. But for everything else, it should be faster. So we will see as we go. The AI server is probably gonna take a couple of minutes, so it takes a little bit of time to actually get on. While we're having some downtime, if anyone has questions, please shoot. Also, like I'm keeping an eye on the comments, so if anyone can think of anything, please let me know. I hope you guys are having a little bit of fun while you're having your lunch, or like just hang out with us, playing your video game while we're on the secondary monitor.
And they're really relying heavily on the transformers module from Hugging Face. Like now, I'm going like deeper in the repo, just try to
Mm-hmm.
explore more and more. And yeah, they try to minimize their work as much as they could, but they are smart. I respect that. Like you're using what other people have done so far, especially like from reliable source, and you try to embed it in your system and just try to enhance it by somehow. So yeah, they are smart. They are smart doing this.
I mean, if there's any library that should be part of your dependencies if you're building an inference engine, it's definitely Transformers.
Transformers, yeah, 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 totally.
Do you want to share your screen while you're doing this, or you're just
Yeah, I'm just going through it. We can, if it takes a little bit longer, I can do that. Yeah, we can share and
yeah?
we
It
can
should
look
be it
through
should
it.
be 1 more minute or so. Just it's, when it's turning on, it's loading up a lot of stuff and a lot of hardware, so it takes a minute.
Okay, let's. I can share my screen and just talk about it a little bit, or like just to explore it together. Whatsoever.
Yeah. This is
Not coming yet, or what? Um, I shared the screen like 30 seconds ago.
okay. I'm sorry. I just saw it right now. Added you to stage.
Yeah. So it comes to you, and you allow to stage it, right?
Yeah.
Okay.
So
Okay.
if you want to load up if you want to load up anything, you can always do that, and then just ask me to like bring it up.
Okay. Okay. Yeah, I was just like exploring this like in the main let's say directory over here, and the first thing usually when I go like further, I just go for the models, see what they are doing over there. And what surprised me actually that they have a configuration for everything they have mentioned so far, like DeepSeek and Llama. and so on. Even Mixtral, like, okay, that's
Yeah, some of them are 6 months old. Some of them are like more of their like initial supports.
Yeah. We are talking. This one is like 2 weeks ago, something like that. So yeah, I choose to go for that further.
Well,
And
can we go for the DeepSeek V3? Like if you go back,
V3, there is DeepSeek.
like the no, this is the old model. I believe this is the original support for the two. Okay, you're fine. You're fine. This is the configuration for the current model. I'm sorry.
Yep. That's for me even was catchy because it was like the most recent one that's been updated so far. So I wanted to check out what they have updated so far over here. Yeah, they stated over here that it's based on like DeepSeek V3 implementation from DeepSeek AI team and so on. Hugging Face, links. Nothing important in this part except if someone wants to check like the original model, it's already exists over here in the Hugging Face. So yeah, if you want just to like configure the model as per your needs, I would say. Yeah, then they use like the transformer and initialize the pre-trained configuration. So this one, it's some exact stuff from like Hugging Face, and yeah, this one. So it's a little bit like nice to explore it. Okay, it opens the same. No. Okay, let's get back here. Forget about it. Okay, they have a bunch of arguments, and going down, you can find the arguments in the initialization. Model type. Column wise and row wise, okay. And then the initialization, this is like the static ones, intermediate, and number of layers. They have 1 to 8 attention head over here. They are basically like more or less using the original configuration of the DeepSeek.
By the way, the AI server is back up. So
server what? Sorry.
The AI server is back up. So like I've got it running. So.
Okay. Let's get back. Let's get back to you.
Do you want to get back, and then later on we can jump back into the?
Sure. We will reach into this part anyway. So yeah. I was like using the
and Cache Yassine MTB is on here, and he just commented that there's so much abstraction in the Hugging Face library, and I mean, like as any project grows, you have a lot of abstractions, and it becomes annoying to actually like work with these projects. So I agree.
Salam, bro. Yeah.
Salam, man.
Yeah, but again, like when you find like such a platform like that, and they are doing a nice effort to collect everything, putting everything under one umbrella, it's respected. Like it's just like Absolutely. You can find anything you want over there.
Absolutely. So it should build now because I actually checked, and now we have the lib64 here. So
nice.
That was So now let's see if it's gonna build.
Nice. Okay.
So once this is done, I believe I've already downloaded the model. Should be just following the steps, but let's see if the steps are gonna run for us smoothly. And if I can, I want to point the API server, like see how can you actually deploy and their server so that I can use it with my Open Web UI interface.
Nice.
everyone. I believe that we have newcomers on here, so just for information. My name is Ahmed. I originally built this thing that was just 8 GPUs, and recently it became this with 14 RTX 3090s, and today we are trying to get the DeepSeek R-1 671 billion parameters model running, but not with llama.cpp, with KTransformers. It's a different inference engine. They announced a few days ago on the local llama subreddit that they have made some optimizations. Jade asked if yeah, it's we're not going to be running the Q8 because unfortunately I have to do a lot of CPU offloading. So what's going to end up happening is that I'm going to use most of my RAMs, which is I have 512 gigabytes of DDR4 RAMs on this system. So I might use 1 to 4 GPUs depending on how it goes. But right now we're going to be using the Q4 just because I want to compare to the numbers that they have in their documentation, which is pretty much a 10-time increase, like from llama.cpp on the Q4 KM, which is pretty much it's an N4. The time to first token went down from 53 seconds to 6 seconds. The prefill went down from pretty much 10x from 10 tokens per second to 97 tokens per second, and the generation almost tripled from 4.51 tokens per second to 13.69 tokens per second. So I don't think anyone has yet showcased using KTransformers, so that's why I'm doing this. I'm not trying to get llama.cpp to work with it. There's a lot of people that have done that out there. And Sleuth specifically, they have released amazing dynamic quantizations that you can use for his llama.cpp. And pretty much it can be fully offloaded to your GPU without tensor parallelism specifically. So that's what we're doing here. Also, most recently, so if you're interested in quantizations and inference engines, most recently I published a blog post called "Stop Wasting Your Multi-GPU Setups with llama.cpp" and explain why you should be using more XLlama v2 or VLLM. As you know, there are among others. There are a lot of them out there. Is it still GGF and KTransformers? Yeah, it's still GGF. Actually, they ask you in the documentation to initialize the Git submodules. One of them is llama.cpp. And we've lost Osama. So let's wait for Osama to come back. I don't know why they're doing that. It's still building, so this thing is quite hefty. Yeah, Kate, 2x, 3x 4090s, and I think for 512 gigabytes of DDR4. Yeah, I don't know if you have like an AMD Epyc server or what. Yeah, like honestly, right now the way to go, and I was talking with a good friend of mine yesterday. He's trying to build an AI server, and he was telling me, and I was telling him that he should go for a DDR5 and with an Epyc 9000 because yeah, an AMD Epyc, yes, absolutely. I mean, please, anyone, if you're watching this and you're considering a server setup for your for AI purposes, do not go Intel, go AMD Epyc. Yeah, I have that same motherboard. Yeah, Osama just messaged me. His connection is down. He's trying to get on. Absolutely. The 7000 series CPUs are quite cheap, but not the 9000. The 9000 are very expensive nowadays, especially with the tariffs and everything that's going on around us. But I would highly encourage anyone, like, do not focus on GPUs right now, because honestly, GPUs are a crazy thing on their own. But when you're building, build for CPU and good RAMs, DDR5. Get yourself some AMD Epyc 9000, and from there, and also make sure that you have good motherboard that supports PCIe 5, that has an MCIO, because you want the MCIO, because you don't want to spend your money on redrivers and retimers. That's another whole thing that ended up wasting thousands and a lot of my time on, because you can't just use the risers that are like plastic and like cable things. These are not good. Yeah, risers, exactly. We were just talking about risers. Risers are stupid. You want to use slim SAS cables with redrivers and retimers, depending on the signal to noise ratio that you're dealing with. There's this dude called C-Bane. He's based in Germany, and I think I spent like $2,000 alone on his website. And yeah, he sells these redrivers and retimers, and these are pretty much like the remove all the noise around the signals. Because if you think about it, you have your PCIe express lanes, and the more space that you have between the cable connection and distance to the GPU, the more noise that could be. And when you have these noise things, they make the signal weakened, and then you end up with your kernel system completely crashing when it's receiving input and trying to send back output to the PCIe. Or through and back to the PCIe lanes. Osama, welcome back. I'm glad you're still with us. You there? Okay, he dropped. Yes, C-Bane. cbane.com. And you buy redrivers and retimers from this dude. The slim SAS cables and the other things that you might need, you can get them cheaper on Amazon, but this redrivers and retimers definitely from C-Bane, highly recommended. But also, again, when you're buying a motherboard, make sure that you have enough PCIe lanes. The one that I have here is 128 PCIe lanes. It allows me to run those 14 GPUs at 8x PCIe 4. MCIO is very important. PCIe lanes are very important. These are just keywords out there when you're looking at an AI server setup. And feel free to hit me up. Actually, I like hardware, so if you need some help, just hit me up on Twitter or LinkedIn or any of my socials on my personal website, which is again ahmedosman.com. So,
yeah. I am back, Ahmed. A bit like
yeah. I'm glad. I'm glad to have you back, because honestly, streaming, it's better to have a back and forth. I'm glad that the people on the chat, and thanks, Cash, for all the questions and all the input. It's way better when you have like interactions.
Sure, but
in these things.
Like a quick recap. I'm like, I have heard you talk about like signal to noise ratio something, and what was the topic?
No, the topic was hardware, the motherboards and like risers for your GPU from the PCIe lanes. So you end up, these risers that are plastic and like, they can be benty. These are really bad. These you throw in the trash, you don't use. But then you end up with like slim SAS cables, and
okay,
can have host adapters and device adapters. That host adapters pretty much like connects to the PCIe lane on your motherboard, and then you can get slim SAS cables up to another device adapter that you connect. So it's pretty much like making a link, a bridge, right?
Yeah.
But when you use the host adapter that doesn't cancel the noise, that doesn't do any cleaning, you get a lot of noise and the signal that is being transmitted, because you have a huge distance now between things that are like supposed to be BCD to BCD, right? Like they're supposed to be directly linked on the motherboard. You can't have that when you have these huge GPUs, unless you're going like extreme water cooled, and that's a whole other thing that I don't want to even get into. So when you have to deal with that, you want something that can clean the signal, right, and remove all the noise, because these noises will literally crash your system. Like, I couldn't keep my system up for 30 seconds loading a model on just when it was 8 GPUs. I couldn't keep my system for 30 seconds running because it will start the inferring and then complete crash and restart, right? Sometimes like it will just shut down. That was very wild for me, and I didn't understand what was going on. But you get these things called redrivers and retimers, and these things pretty much are like take the signal, understand that there's some noise around it, clean that out, and then proceed. And the dude that sells them is called, like, has a website called again cbane.com, and his name is Christian, I believe. Christian, if you see this, please remember that I told everyone here, we have almost 1,500 people watching it. So I told everyone here about that, and I would like some discounts. So, I spent thousands on that website, and I'm very glad that actually there's somebody who does this for consumers, because getting something like this, I think before him as a consumer wasn't viable. So he does a lot of good. Anyway, back to KTransformers. We've got KTransformers now installed. So
nice.
we are lucky that was as straightforward as it was. Now to the next step. All right, so what do we have to do? I wonder if this is gonna have the whole entire model downloaded. I'm scared of that. I already have the GGFs, so like if I go to hub, these are just the models that I have currently on this. And as you can see, again, going back to the Bison bells that I used to do all the time, and we were making fun earlier about how I have an entire notebook just to how to build Bison and replace the dependencies. You can see gmon.out everywhere, because profiling, Bison profiling, just leaves things behind. I believe it was Bertowski. I'm just trying to find the model. 1 second, everyone. Yep, here it is. Okay, so we can go into that, but the whole idea is that we need to do this, local chat, and model path. I think we need to specify just the DeepSeek model, and then the prompt text. Can be local, set from online hackings. Okay, just we're gonna try this, but we might end up failing, but we'll figure that out. So first, let's do a W and grab this entire thing and put it somewhere. And then CD, Transformers, since we have 11, so I already have this thing running. Useful, and so it wants me to create a prompt text file. I'm just gonna do this with you guys right here. Since we're already inside the KTransformers directory, I don't need this. Model pass. It's here. And the model path itself is the Hugging Face 1. Actually, I think I'm gonna download everything except the safe tensors, and then point to the directory itself, just because I'm really anxious that it's gonna download the safe tensors.
What do you mean
I don't have to.
The whole model, you mean?
Yeah, because when you specify a Hugging Face directory, it might end up just grabbing the entire thing, because here it's trying to grab the configuration, the tokenizer, etc. Right? When you're specifying that. So I just want to make sure that we have all of that information saved somewhere, and specify that so that it doesn't download the safe tensor files.
Okay. Also, I'm searching about a potential bug, but let me find it first, and maybe I'll tell you about it if it exists. If it exists.
Anything to remove some of the hassle would help.
Yeah, because I remember like they was using, I don't remember if it's in DeepSeek configuration or in the, I might find it here in this KTransformers like repo, that they are using the distributed model from the module, from Torch, and to parallelize everything they are using torch.nn.parallel, and this doesn't work for multiple GPU. I have an experience with that.
And here's the thing. Again, we might end up just using one GPU and the rest being offloaded to the CPU.
That will be a nice as start point, as an
exactly. Like I'm starting this as simple as possible, because they have talked about hacky workarounds to offload more to the GPUs, but what they are trying to do, for my understanding of everything, so that nobody calls me out if I'm not being as accurate as their documentation, is that they're trying to load the model as like the parameters into the CPU, into the system RAM, and then load up the activated weights on the GPU. So they're trying to hack it together in an optimized way.
Yep.
And now we need to understand Hugging Face CLI. I'm trying to download. I'm trying to just get the documentation to downloading stuff, and I want to tell it to ignore, to exclude. Yep. So I think that they have an exclude thing. Yep, they exclude. Yep. That's exactly what they want. So if we do this. And we say exclude instead of include, then it will download everything we need.
That's the choice, yeah.
And I have a lot of aliases, so anyone, if you're wondering what's AIHF, it's going to a certain virtual environment activating that I have Hugging Face CLI tool installed on. Then we can do this. And it downloaded everything we needed. So that's great. So now we can just say, here's and yep. And I think this is not the right directory. Yes. Yep, that's XML. Okay. Yep, this is the right directory. That other one. And actually, here we need something else. I'm trying to go through this spot. This should have the model configuration. Yep. Has the config.json, has all the things that we need. And I want to create a prompt.
Yep.
Yep. Prompt txt. Let's create that. Just do it here. Touch. Schedule prompts. And then how many the most famous question on the face of the planet at this moment. How many R's are in the word strawberry? Let's just make it look nice, and let's try to run this.
Okay, let me see that on the screen already.
Let's actually, okay. Everyone can see my screen. Don't know what's gonna happen, so let's pray. Okay, of course. Nah. Node argument is 1 out of range. Which argument is that, sir? Okay, so what's the single socket version? Yeah, but this should work. So
yeah, but what I have spotted also over here that in the operators, you have to identify the right device and the right node, and what more?
okay, I need to understand what's the STL. I haven't used STL. Okay, processors shared memory. Runs processes, so is a specific normal scheduling or memory placement policy. The policy sits for command and inherited by all of its children. In addition, it can be set persistent policy for shared memory segments. Okay, interesting. I haven't used this tool before. So it's specifying. So it has to use the N and the M option, right? So the M is the nodes. Oh, interesting. Okay.
Yeah, I have seen that in the operator directory in the source code itself. You have to identify it, unfortunately.
Okay, so we need to identify. Actually, I wonder if actually I need to specify any of that.
Hold a sec. I guess there is no default.
I just wanna run this. Okay, so it's telling me that
the
local. Oh, I see. Okay, let's see what's gonna happen. And I know this looks too small, but the top. Okay, I'm actually gonna run this on a different screen because I just wanna see what's going on. Okay. Of course, flash attention. Flash attention isn't installed. That's just not good. You can even see in my history it's just auto completing everything for me because I had rounds and rounds of flash attention before. So. Yep, it was as easy as that because I've already built it before. And I'm looking at BPOP pretty much on a different monitor to just see if it's starting to occupy memory. It is trying to offload to the first GPU. So it only offloaded 6 gigabytes to the first GPU, and it has uploaded a lot to the RAMs right now. It has uploaded like 70 gigabytes. 82 gigabytes. Yeah, it's working. I don't think I have to specify these things with NemoCTL because I'm running a single socket here, right? I think that they're trying to run that on a two-socket system, which requires you to specify which CPU to offload to. But my system doesn't need that. 200 gigabytes have been offloaded. Actually, I can show each top if anyone is interested. You can see. Yeah, actually. So like right now, it's there's a lot that has been uploaded.
Okay.
Yeah, I feel you. I was telling my partner earlier today that hey, if you know, for whatever is coming next for me, I'm planning on spending like a good chunk of money on an Epyc 9000 system, and I need. And she was like, "Really?" I'm just like, "Yeah, I do need a 2 terabyte RAM server. Yes, I do. Yes, you don't know, but I do."
We're gonna go in a hunger strike to get this money out of this.
I'm open for consultation if anyone needs help with AI stuff. I'm definitely trying to build that system. So
it's really nice, huh?
Thank you. And I'm gonna go check. Okay, it's still loading. Oh, chat. Oh my god, this actually is working. Oh my god. How many
nice
are Huh? I mean, we're not benchmarking anything. Okay, let's see. That's good. So everyone, this is DeepSeek R1, the full model, quantized into Int4, but it's working on my machine. This is pretty fast.
It's really fast. It like as a local, it's really fast.
That's another. Let me think. The word is wait after BE. Oh, 3 R's. Bro, just you got this.
It's the robbery. So let's count the R's step by step. Nice.
He's overthinking. This model is overthinking it, and we're so sorry for putting you through so much stress. But maybe I'm overcounting. Let me check again.
Yeah. You know that's pretty sounds like me. Like let's double check with another method. Yeah. Okay.
I just tweeted it's working, everyone. I retweeted the whole stream. It was like, everyone come ultra success. Three, therefore there's three, so the answer would be three. But dude, just trust yourself.
He's going
trust
so
yourself,
deep.
man. Trust yourself. Have some self-confidence. Okay.
Needs a shrink,
oh
man.
my god! Oh my god! It actually answered. It's with the thing tag is over, and we have an answer. We have an answer. We have an answer, everyone. We know that the word strawberry has 3 R's. This has been, finally solved. Everyone who works in deep learning neural networks, thank you so much for your work. You have done humanity great. Thank you so much. I'm actually gonna take a quick screenshot of this, everyone, if you don't mind me.
Let's talk about the numbers a little bit. It's really interesting. Make me really interested. It's really interesting over here, to see all of that. So
I can't hear you. Osama?
Yeah.
You still there?
Yeah, I'm here. Can you hear me?
Good. Yeah, good. So the numbers. The prompt evaluation count 14 tokens. So I'm assuming this is something I still need to understand, actually, because I don't know the difference. So the ultimately, we got 805 tokens out, right? Yeah, this is how much, this is the number of tokens it's evaluating per second. I think this is the total, including the input. And yeah. No. I think this is.
I mean, in the prompt phase, before the generation is starting. This is the number of tokens before we hit the generation phase.
Yep.
I mean, the 14 tokens.
Yeah, and then it took it 97 seconds to provide us with an answer, and it was providing us with generating 8.2 tokens per second.
Yep.
So these are pretty good. Anyone has any questions to ask to a smart AI model? Cache, you always say that we have PhD intelligence level LLMs, but no PhD level questions. Let's get these people. Okay, ask a geometric questions.
What? Geometric. Okay. Okay,
for 3D printing cross sections. What exactly? Okay, how would you? Okay, that's actually easier to.
we can start by a simple thing like prove that 1 + 1 = 2. That took some scientists around 36 pages of proof to do it. So that's burn the whole tokenization.
We will do that one, Osama, but first I'm gonna run this cache eval real quick because he's saying make me a laptop stand
cross section
with CFG using Python. I am into 3D printing. I have 4 3D printers in my house.
Let's do that.
So this is actually a funny one to me.
Okay, he's trying.
He's trying.
Yeah. XML code. Should I start setting? That's pretty systematic. That's too much details.
Also, we have to keep in mind that this is more of I like to call these the deep thinkers, and these models they just overthink. And I don't find them the best when it comes to producing code, but I find them the best for producing an architecture that I can take to another LLM. And I move between, models like this one. Oh, here's a Python script.
Nice. What I see, like, there is, like, a systematic interpretation for the generation over here. So I'm just wondering how they, like, I don't know, encode this systematic. Like, first it gives you the intro about the anything that you want to know, and then approach the problem with different methods, and then start to give you like one by one solution and explain why this solution is logical. So that's pretty much like into like how the integration of the attention heads inside the transformer itself, and the orientation, and because at the end we don't know how we, like, what's the process or what's the dynamic that create the query keys and values for each word embeddings. So I don't know what exactly trigger for all of these answers. But that's worth a shot to go deeper in DeepSeek and just try to understand the architecture really very well.
Yeah, and that's definitely something I'm actually interested in having like a bunch of streams on. Like as I told you, I think the first time we encountered each other, I was telling you that I was reading the R1 paper, right? I'm actually reading it the third time. Like I think I need a new pen head for my Apple Pencil because I'm just trying to go through everything and fully understand it. And I would love to have an Epyc in this.
Yeah. For example, like why, like the previous questions have previous question had like 14 tokens, and this one has 16 tokens. But the previous question, the answers was 805 or something like that, around 800 tokens. But now we reach into 1,000 tokens. So what's the parameter that controls?
Okay, so actually, I think it stopped, and
it stopped.
It stopped because the command we ran, we limited it at 1,000. We limited it at 1,000 tokens. So just a quick thing, this was communicated already in the documentation of KTransformers that they only offload activate, like the activated parameters, which are 13 gigabytes onto your GPU. So I expected this to happen. This is exactly what I was expecting. And then the rest of the model is pretty much offloaded to the CPU. Now I want to start it again. Like I want to restart it, but with more tokens. And
okay.
But at the same time, I think it's eating up 464 gigabytes of RAM. I'm not sure we can do a lot more. Maybe let's try 2,000, but it might fail. And then I'm just going to copy this.
There is no argument to define these things in the KTransformer itself?
Thanks, Cash. Thanks for stopping by, man. So no, because when you're loading it up, it's pretty much, it's like you're setting the inference engine settings. It's this is very hacked together. Like this is a script. Like max new tokens 1,000, and you can't change that once you're running it. Like you can't do that during runtime.
Okay.
So let's try this. To everyone who joined us recently, because right now we are at 3,300 viewers. Yeah.
Wow.
Yeah. So my name is Ahmed. I have this. I built this. Originally, it was an 8 GPU, 8 3090s AI system, and recently it expanded into this, which is 14 RTX 3090s with 336 gigabytes of VRAM. My system has 512 gigabytes of RAM. I have been playing with AI for a while now. I blog about this, and this is my first live stream. So thank you for stopping by. If you're interested in inference engines, I just recently posted about this. We had a lot of good discussions earlier in the live stream where we talked about quantizations. What do they mean? Why do we have different inference engines? But in short, what we're doing right now is very hacky. We are loading a model. We optimized the llama.cpp to work faster on CPU and like RAM. And that's what we're trying to experiment with right now. So welcome to the stream, and thank you for stopping by. Now, it has reserved. Okay, so I was looking actually at the wrong number earlier, but so far it has offloaded 346 gigs, 357 gigabytes of RAM. And it's increasing as we go. And chat. Okay, so I actually want to try something. 1 second. I'm going to try it on a different window. Actually, we have 115 gigabytes of RAM available, Osama.
Sorry, say again.
We have 115 gigabytes of RAM available. I think we can go up a lot.
Yeah, sure, sure, totally.
Yeah. So do you want to redo it one more time, or do you want to just give it the try?
Let's do it. Let's do it again.
Okay. Sorry, everyone. We're just trying to figure out what is the most optimal way to like make it count R's in Strawberry. You know.
Yeah.
Let's see how far off can it go.
Yeah, the failure point. We are searching for the failure point.
Yeah. So let's try 16, 384, and let's see if what that's gonna get us. This might not load, so I'm not sure. And while it's doing that, I'm gonna just disappear for a minute, and I will be right back.
Sure. Okay, nice.
All right, I'm back. So finally, we got the moment. We got the model running. It's actually that's not bad actually. We still have a lot of memory, but let's see if it can reduce stuff. So let's start with asking it. Prove that 1 + 1 = 2. And let's see.
That's gonna be a thing.
That's gonna be a good one. Someone is asking what is happening right now. Well, we were using the plan initially was to see if we can build and get KTransformers to run with uh, DeepSeek R-1, the 671 billion parameters model, quantized in 4 bits integer, and we got it to run. So right now, this is fully offloaded, except for 13, except for, I want to show this on screen, except for 14 gigabytes offloaded to 1 GPU of my 14 GPUs. This is fully offloaded to CPU. And it is writing it's producing output at this rate, which is pretty good. Where do I even, like, it's asking, where do I even start with this, with that? We are taking questions, so if you want to see how this model would do answering your question, please shoot them our way. We are, like, at this point, pretty much the whole experiment was trying to get KTransformers to work. It's working. It's good. So at this moment, we're just playing with the model.
That's interesting. Like the way of describing the thing and talking, it reflects exactly like that. Tension heads distributed differently, and even the localization during the fine tuning is totally different from I would say, the normal one that we have seen so far in GBT or in other models. And as I said, like that worth a shot to go deeper and find out how this architecture is being built and the training, so on. That's a lot, a bunch of information like you can find over there. Because I like it, systematic way. I like it.
Jade, you asked, no, they are actually being shown. It just, when it starts the output, it removes the thinking tag, but you will see at the very end the thinking tag given to us. So it's just, I think it's just one of those things that they decided to, or by mistake probably, just not show at the beginning. But the tags, this is the thinking tag pretty much. And Osama, to follow up with what you're saying, like, honestly, right now, we still have like almost 100 gigabytes of RAM available. This makes me wonder, if I for a different day, because it will be a lot of work to do it like live. If we can optimize or, like, configure KTransformers to offload to both all my GPUs and
exactly
the entire all the system RAMs, then can we load it in full precision? Can we load it in integer 8-bit? And see how that works. I'm very interested in doing that. Like, at this point, I'm definitely gonna work on getting that to work, because my VRAMs 36 plus 512. Yeah, that's 848. So yeah, I want to see how that would run with a model like this.
Yeah, I can see a lot of potential stuff that can be done over here, like starting either going deeper or going higher, like by developing something on the top of this. So, but like, yeah, this step was really, like, I would say, important to find out if it's gonna work with like some accepted level of efficiency.
I mean, this is pretty accepted for me. Like,
yeah, sure, definitely.
It's reading speed, but it's also slowing down as we go, which is expected because it's evaluating more tokens first,
exactly,
as it outputs more tokens.
Yeah. And this is very interesting question for me. Like, what is the number of tokens, the evaluation number of tokens that like we expect to be generated by some prompt? Like, let's say, okay, I'm using like 14 or 13 or 12 tokens in the prompt, but at the end, can I predict the number of tokens that's being created or generated by the model itself, or it's gonna be like up to the model in any case?
So that you're talking about whether it's predetermined or not, like that the
The
deterministic
deterministic
side
or
of
not? Yes,
things.
exactly. Yeah.
And I don't think that. I think that that's a big topic that a lot of people argue about, right?
Yeah,
But
sure.
you get the same looking at samplers and the randomization that occurs when you're just setting up your sampler. That alone can diverge these results by a lot. You might want to look at running it 100 times and seeing the distribution of it, though. I think you're lagging, Osama.
Sorry?
I think you're lagging.
Yeah, I'm lagging for a while. Like, I have some interruption in my connection over here. So I don't know what's the problem. Even like I emailed the service provider right now to see what's the problem, but still like it's unstable.
Yeah. So to summarize my thoughts, using piano axioms, we define numbers
Can axioms,
recursively.
yes. Okay, nice.
I think it's getting to the right results. It might be
Yeah.
taking it a
Totally,
minute,
totally,
but it's
totally. Yeah,
getting to the right results.
yeah.
Yeah, and Jade, as you can see, the end tag for thinking, it's here.
Mm. Oh my God. Even go deeper. Oh, nice.
And this is the conclusion. Actually, it's already done with the thinking. It's just outputting it in a concise way.
Yep. Yeah, that's pretty right. Yeah.
Mm-hmm. No, it got it. Like it actually got it pretty right here. And viewers, if you have any questions to R1, the full model quantized in 4 bits integer, but it's the full model, the 671 billion parameter model. If you have any questions for it, shoot it. Because I actually am trying to like just get this model to answer questions for us right now.
Okay. Conclusion. One. Okay, 700. That's a lot.
Yeah. So eventually it went down. It went up to 2,000 tokens, right? And then the evaluation rate definitely went down. Like I think we were looking at 8.9 seconds last time. 8.8, 8.9 tokens per second last time, and I think it's just doubling the number of tokens it had to like consider. But I would say that that's on par with what their documentation showed.
Yeah, I'm
And
check. I'm
again,
checking. Mm-hmm.
again, they were mainly looking at 1,000, and you can see the numbers, the benchmarks. Definitely, the pre-file changed. I'm actually just curious about the tokens.
Number of tokens exactly. Yeah.
Mm-hmm. But I know that our numbers match these numbers for 1,000 max new tokens. Now this makes me wonder if we should give it another prompt and see how low it would go, adding 2,000 more tokens. I'm very curious about that. You have a question you want to ask it? We can literally ask it how many R's are in strawberry, because we haven't this time. So.
This is a new one, new prompt, correct? Yeah.
Yeah.
Okay.
Because this is a new run of the model.
Do you think if it runs over like multiple GPUs, gonna reach the benchmark that they have mentioned in the documentation?
They said that for CPUs that support the Intel XM 524, you can offload to 4 GPUs, and they said that led to like a quadruple increase in tokens, if I remember correctly. So I'm very curious about how will this work without these instruction sets, because my current setup, I'm running an AMD Epyc 7000, the 7000 series, and I don't have that instruction set in my CPU. So that's definitely something to like wonder about. I think the best way to go about it is actually trying to get it to work. So. Man, I actually, when I started this, I was thinking that's going to give us like it's going to be a lot more difficult to get this to work.
Oh, it was really straightforward. Yeah.
Yeah, it actually, like, besides the whole coda thing that took us like half an hour to get running. In case anyone is wondering, again, we are KTransformers team. It's an inference engine. They released recently a new optimized version of their engine for R1 and V3 of the DeepSeek model, allowing pretty much, according to them, the prefill. And I cannot test this because the prefill requires the instructions that I was just talking about, but it's a lot faster than llama.cpp. And we were just trying to get that up and running today, and it's up and running for us, and we are getting it to count the R's in the word strawberry right now. Jade is asking, is random sampling enabled in the inference? I think it might distort any evaluation measure if we don't just pick the LLM's most probable token. I believe so, but we can't check. That's something
I guess so as well. I have spotted something about the sampling, maybe top K or something like that in the code, in the source code. But yeah, I believe it's activated in the inference as well.
KTransformers, and you can just take a quick look. And it's the local chat.py file that we're running right now, so we can just open that and take a quick look at it. What does it consist of? So again, getting the modeling, etc. stuff, specifying which architecture, and these are your arguments. And from there, yep. So It's using the. I think it's using the default. It's using the numbers you send it, except that for that it uses the defaults. From pre-trained model pass. What does model pass lead us to? Oh, it's using the default. It's using the default model configuration values for temperature, etc. So these are directly picked up from the model's default values. Does that make sense, Osama?
I'm searching about something different, and because I have spotted something clearly about this, but I'm just trying to see it over here. I didn't know where it's gone, but I highly believe it supports the random sampling.
And honestly, one of the things I want to do right now is try to see if we can get a server running with this so that we can actually use an OpenAI API endpoint with it. So
yeah, that would be a nice experiment.
all right, so it's finished thinking, and it's agreeing that we have three R's in the word strawberry.
How many tokens? List yet? Okay.
I think I think at this point it's sticking to that 3.5 evaluation rate. But I'm just wondering. Now, this makes me wonder, is the max new lens causing this? Like, does it allocate something and it just has to go all over it? I don't know. I don't know how CPU offloading works, honestly. And Jade is asking that he didn't know that models actually have the numbers like the defaults. So I'm just gonna show something real quick.
Yeah, I have found it for random sampling. It's in local chat.py. You will
So
find
this is the file, the local chat.py. Yeah.
.py and under KTransformers. Yeah. You will find it in the try except status.
Yeah, and the thing is, what I'm trying to say is that it's trying to generate it from the model path,
exactly
from the configuration, which is this pretty much, right? So it's originally trying to grab the defaults from here, and then it fills the rest with whatever the inference engine believes should be the defaults. So that's how it goes.
Yeah. And if it fails, it goes into the other sampler or the sampling techniques that classified like the 2K and the 2P in the except states, like by identifying the temperature, the 2P, the do samples as a true, like this temperature 0.7, it identified the randomness that we need over there. You can manipulate that and you can change it over, increase it or lower it down, it depends on you. And the 2P is just the parameter for like the what's called the nucleus sampling, I guess, something like that. It's also another random sampling technique. So as I said, sorry.
Yeah, go ahead. I'm sorry.
Yeah. As I said, like the KTransformers supporting the random sampling, and otherwise we cannot actually find these results without it.
Exactly. I mean, nucleus sampling is your go-to nowadays, right? It's the most popular one.
Exactly.
Now I'm just wondering if there are more if there are more arguments that you can send to it. But I'm not seeing anything. The max output token. Attention, if you're testing R1 and it may skip thinking, so you can add the argument force thinking. Oh, I mean, it's not skipping it, but do you want to try to play with it?
Okay.
Yeah. And should we stick with this high number of input tokens, or should we just bring it down to like 4,192 maybe? 4,096, sorry. 1496. I just want to see how, if this affects or correlates in any way with the evaluation tokens per second.
Yeah.
Just an experiment.
Yeah. Because now we are benchmark our experiment against what they have seen, what they have mentioned
Exactly.
so far. So
exactly.
It's important to find out what's going on with different parameters, the set of parameters.
Yeah, and I'm gonna apply the force think argument too. So let's let the Hunger Games begin.
Let's see. Force think. Nice name for an argument, like thing. God damn it. Is it working, or because you are sharing that?
It started. Oh yeah, I'm sorry.
Yeah, you are sharing the tutorial page.
User warning: the given by array. Okay. Actually, I want to go take a quick look at the project source code, because I want to find the sampler defaults. I'm pretty sure that they have defaults. Models. Face tray.
You are revising the source code for the DeepSeek or for the
V3. The DeepSeek. I mean, this is the DeepSeek model specifically, the implementation of the model's architecture in
because the sampling is really totally model dependent. It depends on the model and the definition of this parameter of it. Yeah.
Hey, Versailles. Good seeing you here, man. Yeah, you see? It's okay.
It's still supporting. Okay, nice.
So it gets past it.
Yeah.
So which in this file says the gate. So up here, configuration gets sent here. So I'm just wondering, where does this? And this file. sends this from the decoder layer, and the decoder layer gets this. So where does this get called? It's called here. This AVL3 model. Okay, so it's configuring DeepSeek. Okay, let's actually look at this very, very quick. Okay, here we go. Normal top K probability, and it's telling you the default values.
Default to true.
So it has defaults.
It
has defaults.
Yep.
Yep. So Jade, if that answers your question, it's loading some of it from the model's configuration, the config.
Otherwise, if it doesn't if it doesn't exist, also like KTransformer identify the main parameters for this.
Exactly. So
to just be sure that the random sampling is happening during the
exactly. And now let's go back to the model. It's probably yep, it finished loading. So good stuff. Again, we enabled first thinking. We decreased the number of new tokens to be outputted to 1496 to 4,000 tokens pretty much. And now let's ask it something. What? Do you want us to ask it to prove that 1 minus 1 equals 0?
That's a pretty, like, I remember 13 pages, something like that. So let's see. Let's see if you want to
I mean, I want to see this thing, you know. Okay, again, Jade, you're asking about this. So the first thing forces it to actually like output this thing tag. So
is it faster, or did I get it wrong?
I feel like it's always faster at the beginning. It slows down because again, it's evaluating more output tokens. And this makes me very like I have been wondering if allocating a higher number of max new tokens forces it to look over a wider wider amount of memory, basically, even if it's empty. So this is something that honestly, unless you can like dive deep into the code of the project, into the inference engine, and figure it out, you're better off trying to like just experiment with it, play with it a few times to figure out. I'm actually starting to like work on this inference engine, but it's not easy. Like building an inference engine, everyone, it's not easy.
Sure, totally.
You have to implement, if you're using PyTorch, or if you're using Torch, or if you're using JAX, you have to figure out what hardware you're supporting, and then you have to figure out which model architecture you want to implement.
I guess the main challenge comes in the distribution, like how you distribute your stuff, models, data, everything, which maybe you're gonna need like to build up your modules actually. Because like I remember PyTorch, PyTorch, they have a huge problem.
I mean, Torch is the C++ implementation. PyTorch is the library, in Python. It's the wrapper. Jade, just quickly, here's the think tag. We added the option force think to it when we were running the command, and now it's outputting it at the beginning too. You made me curious about that part. So, Osama, let's go back to what you were saying, because I think if we dive a little bit deeper into it, we can get some good information out. So you're talking about the sampling part, right? When you're building a quantization, like when you're building an inference engine. Sorry.
That I was talking actually about the parallelizing, like doing the data parallelism, or like which module you are gonna use in if you are using Torch. because it's been tricky. Like if you are running, like most of the people, even I have that. Like for a long time, I've been working on AI applications and AI modeling, but I have very few experiences about like working on multiple GPUs. So this is an experience by its own, because most of the time you are not using the same modules. You are not using, you are using mostly the same frameworks, but not the same modules, and you have to do a lot of by your hands, and that might reach to change part in the source code sometimes in some modules. So that's what I was talking about. Like, to guarantee that everything works as per design, you have to check part by part, and keep your eyes open for the differences in the frameworks implementations.
Yeah, exactly like implementing. First of all, there's tensor parallelism, and then there's pipeline or data parallelism. These are two different things, and then you need to think about how would your parallelism work exactly on every infrastructure, like on every piece of hardware that you're trying to support, right?
Yeah.
There are too many layers for this, and everyone, like I tried to dive deep into this in this blog post right here. It's on quantization, it's on inference engines, but the implementations, I even talk about the architectures, right? There's a many layers to this. I even talk about it here, like there are several layers to how an inference engine works. All right, you start at the bottom level. You start with, are you doing CPU only, CPU and GPU mixed, GPU only? There's TPUs, NPUs. There are many things that we coming out right now. And then it looks like, okay, the hardware details of that itself, right? Are you the Intel, AMD, ROCm, the CODA level higher? Then you talk about quantizations, level higher the architecture. There's a lot that goes into this.
True. Yeah.
Like like the dude that implemented, the dude that built Xllama, I respect him so much. So like if he sees this, I just want him to know, like, I respect the work he put into Xllama so much, because he built and he's a one person. He doesn't even, like, I haven't seen him accept BRs into his project. He supports models architectures, and he created a tensor parallel inference engine that supports so many models, and it works great. Whenever I'm like trying to run multiple models, EXL2 quantization is my go-to. I can send 50 requests per second, like, and get the output I'm expecting. He built something like enormous in my opinion, and he did it by himself. And like just the idea that somebody can go out there and, like, just for fun hack an inference engine that is actually production ready, to me that's like mind-blowing. Because like I'm sitting right here trying to like just configure this thing, and I mean, like, I write good code, but I don't think I want to like sit down. I don't have the discipline to sit down and work on an open source project that is production ready. And some people do this shit, and like, excuse my French, and like I have huge respect for open source contributors that actually build real software and not just like a CRUD app. So now, well, it concluded by these principles. So it's almost 2K, and it's 7. Like the evaluation rate is 7 tokens per second. It took it a minute and a half, like a second and a half, to evaluate the prompt that we sent in, and it produced 1900 tokens in 264 seconds. That's 2 minutes and 20 seconds. Yeah, 2 minutes 22 seconds, 2 minutes 24 seconds to provide you with a proof. I don't even know if this proof is honestly correct or not.
As long as it mentioned, like at the end, the pianist axiom. So mostly it's true.
Yeah, it's finished thinking, and then it provided us with. I provided us with like a summary.
We are talking about like here 1971 divided by like.
I'm just gonna answer Jade real quick. Only we out of my 14 GPUs, we're only using one, and we're using 13 gigabytes of one of them. The rest of this, about 300, yeah, about 300 and like 75 gigabytes are offloaded to the CPU. I'm sorry for cutting you off, Sam.
No problem. I'm talking like it's 1900 evaluation count in duration 264 seconds. So we are talking about like one token per 7 seconds.
No, I mean, it's telling you right here 7 tokens per second. Right?
Yeah, one
So
token per 7 seconds. So this is
yeah.
Yeah. This is the like the results from dividing this 1900 over 264. But what they have mentioned in the and just check the repo right now, 5 seconds or something like that.
No. Let me just write this real quick, because I wanna, again, um I have doubt that the increase in number of max new tokens is the factor in like evaluation rate being slower. And I just want to, like, this is what I would call a vibe check, just testing something out to see if it's, if the premises of a theory is valid just from vibing, like with benchmarks. And then if there's some truth to it, then we can look deeper. Now the numbers, and again, they had a max of
6.
one.
Yeah.
They had a
Yeah.
max
Of 1. Yeah.
of 1,000 new tokens, and when we did that, we matched the 13.69.
Yep.
For generation. So we did match these numbers by replicating their exact benchmarks, right?
Benchmarks,
Like
exactly,
by
yes.
replicating their run for
Yeah.
benchmarking. Now we're doing something different. We're trying to play with the arguments, add a little bit of more tokens, like add some more tokens in the output, and we want to see if these numbers, change based on the increase or decrease in the number of expected number of tokens.
Yep. Let's see that. I guess this will be like pretty everything we wanted to do it for today, right?
I'm trying to think of whether we should get llama.cpp up and running really quick, because that shouldn't take that long, and test run the same exact model.
To evaluate the
I mean,
differences.
yeah, I want to see how will this work with the same pretty much replication of the settings, just a different engine. And if it meets this, then okay, we know for sure. Also, it has been on my mind to get llama.cpp running. Again, funny enough, I say in this blog post that I shared, I say to stop wasting your multi GPU setups. But right now, I'm curious about how llama.cpp, to stop wasting it with llama.cpp as your inference engine. And right now, I am very curious about how llama.cpp would work if I try to offload more on the GPU side and use my CPU just partially, more than the 13 gigabytes that are being offloaded right now to the GPU, because we can specify that, we can control that.
Yep.
Raphael is asking, it's still slow, right? I mean, this is not slow to me, but I'm seeing a consistency in like increase or decrease based on, so far, from just vibing with it, from the increase in maximum new number of tokens to be outputted. So setting up more than 1,000, and again, just for everyone's to be clear, you set this thing up max new tokens, and when I increase that 16,384, it became a lot slower. So right now, we're trying to get it to the max, which we set at 4,096, maximum number of output tokens, and let's see if the evaluation is going to hold still at 7.5 tokens per second.
Ahmed, I will be right back in a sec. Okay.
Take your time, man. Yeah. Jade is asking, are all expert layers used for an equal amount of time? Are average? I'm not getting that. If not, it might be a nice optimization to offload nice layers. Jade, can you maybe elaborate a little bit? I'm not sure I'm getting what you mean. But I'm pretty sure that inference engines out there are trying to optimize so many things. So just let me know what you mean if you can. Okay, so it's finished thinking. Finished thinking. Okay, yeah, it's holding still. That's very interesting to me. It's holding still at 7 seconds. I mean, it decreased a little bit from 7.5 to 6.9 tokens per second. But I think there's some kind of a correlation between the number of tokens, like max new number of tokens, and this thing, and the evaluation rate, or how many tokens it's outputting per second. Because here it was 7 to 411. It might be that, honestly, it might also be that it's I'm not sure if this thing is keeping the context at this point. I think it might, because evaluation count 2138, this tells me that it's pretty much throwing away all the context and starting over. And this makes me wonder if it's just slowing down as you increase the number, as you get more tokens outputted. And that makes sense, because when you have more output, you have to evaluate that output as you're producing more output, right? So that absolutely makes sense. Now, what I'm interested in doing, anyone, I'm just wondering, anyone has any questions that wants to ask this thing before we move to llama.cpp? Because I want to replicate this in the llama.cpp inference engine. So I give you guys like maybe a minute and a half. Yeah, maybe until like 3:14. If I see any questions, first comes first serve. Like it's like a queue. So first come, and if I get anything, I'm gonna ask it, and just try this one more time. Because if we get more evaluation tokens, then maybe we can prove that this is just related to that. Also, everyone, you're about to see my cat. He's about to jump on the chair. So his name is Mojo, and I'm actually very surprised that he hasn't been in my office so far today. I think he's annoyed by how loud I'm speaking. Yes, he probably is just like, man, you're usually just listening to music and writing code. What are you doing today? And he's looking at me. In case you're wondering, I have 3D printed this thing for him to scratch him. He likes it. I'm not seeing any questions, and it's if I don't see anything, I'm probably gonna move on to the next thing.
So llama.cpp.
Yeah. So what I'm seeing here, I don't think it's keeping context, and I was telling people.
Okay, let me check.
I was telling people this. It's not keeping context because the evaluation count got higher. Okay, so I'm assuming that it's just emptying everything once you hit the prompt. And what I'm seeing is that the higher number of tokens outputted.
Yeah,
But
true.
although this makes me wonder, because also in the last run we didn't have that much in the evaluation, like in the output, and it was like 3.5. So this is making me more inclined to believe that this has to do with the next new tokens. I'm gonna try this one more time for one reason.
Okay.
I want to ask it this very same question: how many are in the word strawberry, right? And based on but I'm gonna set the argument to 2048 tokens, max new tokens, and let's see the evaluation rate. How about that? We're gonna cap it at pretty much this, right? Closer to this, and let's see the evaluation duration and rate. And after this run, we're probably gonna go with llama.cpp to just get it up and running. Yeah, this is gonna take a minute there. And again, it uploads something like 14 gigabytes on the GPU, and then the rest is on the system memory. So Jade is saying the mixture of experts LLMs choose a small amount of expert layers for every take token to generate. I was wondering if there are any expert layers that are picked. If yes, inference engines could prioritize these. I believe that happens a lot, by the way. Like I think Osama might speak a little bit more to this, but I think that the expert layers are usually picked up, like in a determined way, based on the prompt you submit. I don't know if you can see that.
Let me.
Can you
I'm
look
checking
at
the question. Yeah.
Yeah, can you check Jade's last question?
Small amount of expert layers for every token. More often than other, if yes, a precision could be. So, yeah, expert layer, even like it's supposed to be like a part that can let's say subset the neural network component itself. But how it works in DeepSeek, that requires some deep check. I don't want to say something like misleading information about it, but
I think you can just talk about mixture of experts, like just as an architecture, generally speaking, not specific to the DeepSeek model. I think that's a fair assumption.
okay. But yeah, again, like it's all about I don't see the relation between the expert or the expert layers or even any parts of expert layers in the process of the inference engine can affect that much. Like I'm just checking my head like what's about the gating, what about the sparse, what about the load balancing, but I maybe the sparse can lead into like faster inference or lower memory, but I'm not sure that much, but I believe like it's not that much like affecting a lot regarding the inference at some point. um, maybe also I don't know. Maybe the gating. Actually, I need to check it. Check this out. Like especially with the DeepSeek, what is going on.
I understand that, and I think that's fair.
Yeah.
I'm sorry, Jade. We might have answers for you on our next stream. Like, I'm actually
Yeah.
gonna
Yeah.
read a bit on this later tonight because I'm curious now.
Yeah. 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 And maybe even if I find something like interesting, I will get back and just post it in the comments over here
Yeah,
as a resource or a material that. But I'm just like I'm actually now I'm thinking about it. Like what part in the expert can affect the inference except the sparse computation that happens over there. I don't. Okay, I need to check. I need to check.
very curious about the evaluation of this one.
What's the results of this one? Not yet finished.
No, I'm saying I'm very curious now. Like, it's actually talking a lot more than usual. Okay, finally it's finished thinking. Let's see.
Okay.
Yeah, I think it has more to do based on this. I think it just has more to do with the number of tokens, and the more the more output you get, the higher the chance. Not just the higher the chance, just the slower it becomes at generating tokens. I think that there's a reason that they capped it at the time. Which
But you
makes
know,
sense because you have at that point you have layers on like offloaded to your CPU, offloaded to your RAM, and you have lower bandwidth, and you have bidirectional movements, right?
yep.
So of course it's gonna be like I don't want to say exponential because I haven't done the math, but it pretty much like not exponential, logarithmic, but like pretty much you start to see that effect that you're gonna take longer and like an extremely longer amount of time that the more output you get.
Mm, yep.
All right. Let's do llama.cpp just because I want to see if the numbers are gonna match. And again, I'm someone who believes in building everything from source, so that's what we're gonna do. And everyone, say hi to Mojo. That's my cat. He sits on that chair and he pretty much watches me all day. And if I go outside and I sit on a chair, finally, he needs to jump up and cuddle with me. So I think this is his like this will do, old man. I'm just gonna sit on the chair here until you want to sit on this chair.
So Jade dropped another comment about like I mean when there are three expert layers known to be big very rarely for token generation, the inference engine should pick these to be offloaded to CPU RAM. So I don't know what's your take on this, but I believe like KTransformer has the configuration for the number of experts and the active experts. The one that
Yeah.
they're supposed to upload on the CPU and the one they should not. So I don't know. I need to let me check the code again, the source code. Try to find
Uh,
it
do you
out.
do you want to share your screen? Um,
Um,
if you want to do this interactively, you can take over while I'm getting
okay,
Llama CPP to build.
one second.
I'm sorry, everyone. Just 1 second, please. I'm trying to figure out something here. All right. Let's build this thing. And again, like this is one of the things that I always talk about. Don't stop wasting your multi-GPU setups with llama.cpp. There's much better options for batch inference and tensor parallelism support. However, if you think about it, llama.cpp has the best support out there for models and architectures. And D is just like, if you think about like a new model being released and you want it to work out of the box, your best bet is that llama.cpp is going to have it supported. Yeah, so many bindings, and it works out of the box. So like kudos to them for building something so good. For an everyday, like these are the supported backends, right? Like Abbott Silicon, the metal, they support. I don't even know what these architectures are. I'm just assuming different different CPU architectures. MTT GPUs like NVIDIA GPU, AMD GPUs, Vulkan. I didn't even know that they supported Vulkan. That's interesting. So like these are things that you have to like optimize so much, and like it can go down to the model's architecture itself. Osama, I don't know if you want to take over, so like let me know at any point.
Yeah, I'm just put everything together, so trying to.
And if you share your screen, I'm not gonna put you on the stage until like you're ready. So.
Okay. 1 second.
How to build. So now that we have seen KTransformers,
I found it. You can.
All right.
So the thing is here in. Okay, let's wait. Yep. You will find this in the KTransformer. They are using this module from the Transformers package from GitHub. From Hugging Face. So we are here about the mixture.
Do you want to zoom in just one time? It might make things a lot better. Yep.
It's coming.
Thank you.
But now it's better?
Yeah. Thank you.
Okay. So we are using this dude over here. So before to see where we are using this one, let's check actually this module itself. And that's one over here from the Transformers package, and it identified the let's say the everything that you need to know about the expert and about the layers, starting from the number of the local experts that you want to like assign for this for your task, or the output routers, and even the sliding windows, and all the, let's say, the tiny little parameters that really do the main job regarding the performance and the accuracy, the trade-off between the performance and the accuracy. So this module is really nice if you want to like get deeper into like how they operate the different three experts. Like this one explained to you with the like the whole parameter definitions by default that already exist over here. So that's basically everything about this module, the configuration for the mixture in the transformers from Hugging Face. So here, how they use this guy. So they assign it in the configuration, and here we can see in 209290 that it's a part of the attention itself. So that means all the expert is get the to be defined during whatever the during the interview, during the inference with the by default. So you don't even need to bother yourself about it and see if it works or not or whatsoever. Also here, I guess here this is pretty like a normal assignment. Here, here, here. Also in the pre-trained model. So also even during the training, and here and here. So it's pretty like distributed over the whole file to be sure
Mhm.
that in every part, in every process, that we have this the definitions for all our experts over here. So
Yeah.
the matter of fact, if you want to play with it to see, to benchmark the performance and the accuracy differences between different experts and which one gonna affect more on the offloading on the CPU, I highly believe that we will be in this area. So we need to play in the main configuration of the mixture in the what's called the KTransformer package.
Okay.
Yeah.
And that would be a huge experiment, by the way. Like, this wouldn't be easy. Like we would need to think about a systematic way to do the benchmarking.
That's
Like
hyperparameter optimization. That's Optiuna, assign task, and let it runs for like 3 weeks or something like that.
exactly. It's like just have a bunch of tasks on very expensive computers running for weeks to figure out which parameters should be set.
Exactly.
No, it's honestly the fact that this works is mind blowing. Like the fact that deep learning works on such a scale that now you can talk with it and it
Yeah.
understands you.
Yeah.
It's huge. It's I majored in both computer science and data science, right? I went to college that had a very good data science program, and I decided at the end that I wasn't interested in research because I knew two things: you either go into a certain domain like economics, biology, etc., and focus on like building models for that, or you focus on research, pure research in the data science itself and machine learning, because hopefully one day you might be able to produce something that works. I liked building stuff right away, so software engineering was the way to go for me. When ChatGPT was introduced to me back in 2022, I was mind blowing. I was like, man, I thought that we are 20 years away from this. The fact that it can understand you, it can make connections, that these layers actually work like a brain, right? Like these neural networks, they kind of like, different architectures try to reassemble our brains in different ways. So maybe one day you can have something that is closer to how we think, but also like Cache always has this question, or like he always says this, like, we are trying to get a PhD level AI model, but do we actually have PhD level questions to ask them to like, see if they really know what you're talking about?
Yeah.
So we're moving in a like the times are very interesting. Like the times we live in, and I'm not trying to be like philosophical here, but it's very interesting to see the impact of this on our daily lives and the fact that
Yeah.
there's a lot of things that like right now I cannot think about writing a piece of software without using LLMs. Like, and I have tweeted
Totally.
this
Yeah.
before. Like, I have tweeted this before. Like, LLMs are great for writing code, but that ain't engineering. We still need to be able to do engineering, but it has been a huge like 100x productivity boost for me when it comes to like getting projects out and like doing things and like just getting things experimented with and then moving to the next thing. Anyway, thank you for the walkthrough through that configuration file. And again, I think Jade, Osama tried to answer your question here by showing you that it's very complicated and that you need a research lab to actually play with this. You need at least 16 H200s. So
Yeah.
man, and if you have the money to get the 16 H200s, please consider Osama for consultation. He will get it done for you.
Yeah,
he would
hopefully, but
only
you
take
get the
two.
tools.
He would only take two of those H200s. He would only
Exactly.
take two of those 16.
You
So,
get the tools and we split it together. Don't worry.
yeah, exactly. All right. I'm gonna go back to building llama.cpp, and because I really want to do that. But I know, Osama, that you told me earlier that you're in Germany. I'm in the
Yep.
US,
Yeah.
and the time zone is huge. It's almost 11 p.m. over there. So I understand if
Yep.
you wanna, like, call it for yourself. I'm still very energetic, and I'm gonna be doing this for the next for a little bit. I don't want to say a specific amount of time, but like I'll be sitting in front of my computer anyway, so I might as well
Yeah.
be speaking while I'm doing it. And these
Yeah.
guys are fun to hang out with. So everyone, I'm sorry that there will be less interactivity. I won't have Osama's great insights, but thank you so much,
Thank
Osama,
you.
for hanging out with us today. And I'm pretty sure that we're gonna do this again soon, just for a different thing.
Thank you, man. Thank you, Ahmed, for having me really today. I know it came like spontaneous, but it was really nice. It came way
Yeah,
better than expected. So it was really cool. And
me
yeah,
too.
I used to never let any man behind, but really it's a bit time. So I cannot say my focus will not be here. So I will start saying like, nonsense stuff.
No,
So
I get it. I get it. No, man, I'm not gonna keep you up anymore. Thanks a lot for joining me today,
thank you,
and
man. Thank you,
we'll
man.
be seeing you again. That's for sure.
Sure,
Thanks,
sure,
man.
sure. You're doing really nice, crazy stuff, I would say. But yeah, it's very, very, very interesting. I would really support this with all what I can. So yeah, from my side, have a nice evening. I hope evening is soon for you, and
Yeah.
yeah, hopefully catch up again later.
Thanks, man. See you.
Bye bye. See you.
All right, everyone. It's just you, me, and I. Um. So we're gonna go in here, and again, our goal here right now is to actually get the same model, same quantization up and running with llama.cpp, and then compare the numbers to their official benchmarks to just see if it's really that huge um, in performance. Now, CPU build. So they have different builds. You guys need to bear with me a minute while I'm trying to figure this out. They have a CPU build, and then they also have a GPU build. I'm pretty sure of that. Oh, yep. They have a build for Coda. Okay, so we need the toolbox packages. Okay. Okay. Toolbox installed by default. So I don't know what's this toolbox, but let's figure it out. Toolbox Arch Linux. And oh, I don't think we need this actually. Never mind. This is if we're running this containerized, and I'm not interested in that. Okay, so the good thing is I know that we have NVCC, so I'm just gonna run NVCC real quick. Okay, so that's good. And I don't think that we need to override anything because I have just that one kind of GPU. So Let's just run the cmake build command and get it building. I remember I had like a huge Hey Note document with the installation, with the build and installation instructions, but I'm afraid it might be outdated, so I'm just going to do the default for now. Let's see if this 64 cores, 128 threads CPU is going to do this fast, or if I still just need to sit down and wait for things to come. Yeah, it's gonna take a couple of minutes. But again, so I think we have matched these optimizations. Like we have seen these numbers. I want to see the llama.cpp. I want to see if actually getting higher output, it would be generating at the same rate, or if it would also decrease. My assumption is that as it evaluates more token and as it outputs more tokens, we will end up with longer time for that output being produced. So this is just a benchmarking, like a very unsystematic benchmarking session, and I'm also curious about offloading to more GPUs than just one, because, and this is something that we will need to figure out on our own, because I don't think that there are like clear directions on how to do this. But I'm very happy about the fact that I can honestly run DeepSeek, even if it's. I mean, I have 14 GPUs. If I run KTransformers and offload one of them, like offload one to a half as GPU, and have that DeepSeek R-1 running besides all the other models I'm running, that's pretty good to me. Like I haven't been actively using the 512 gigabytes of RAM, and to me this is huge. Like this is gonna definitely be a huge quality of life improvement, because DeepSeek doesn't answer half of the times. The API is down, and I'm not planning on recharging my credits, because. And actually, today I saw a friend of mine was tweeted that they are not even allowing him to recharge. They are not they are not allowing people to buy credit anymore, because they're just saying they don't have the resources to allow people to use their services. And also the fact that my data is the main reason I got into this whole thing. I started with a 4090, like an RTX 4090, and then I added a 3090 as single. Like I had 2 GPUs at some point last year, and that was all. And the main reason was that in 2023, like early January 2023 specifically, I was submitting an application for something, and I found myself giving ChatGPT a lot of information about myself. I like to give information that, I like my input to any proprietary model to be stateless. I don't want it to know anything about me. So that was very important to me. Privacy and keeping my data secure, and not giving it to OpenAI or DeepSeek. These are important things to me. I don't want them to have even my projects, if they are throwaway scripts. Sure, Gemini Flash Thinking. Gemini Flash Thinking is an amazing model, everyone, right? But I'm only using it to generate scripts that I know I'm going to throw away, that have no importance. It's not like I'm making it build a huge project for me. Clearly, building code objects for this thing is going to take a minute, so we're still at 13%. So this is going to take a minute, and I hope you guys can just bear with me. But again, I was talking about Gemini. Gemini is like I usually say do not use Google for anything like to build your applications, because you never know when they're gonna like kill that product. So you know I'm never gonna use Gemini like Google's SDK for Gemini, for example. I'm always gonna use OpenAI endpoints because I want to make sure that it's a plug and play, drop and place replacement anytime. I'm not If Google kills something, my entire code base isn't affected. But Gemini Flash Thinking is such a great model. It allows for 1 million tokens input. The generation is 64,000 tokens, and it pretty much one shots so many scripts and working code for me. Like, you just tell it what to do and you give it a good prompt, it will generate something huge, like thousands of lines, and it will be generated in such a short amount of time, like maybe a minute and a half, for like 2,000 lines of code, and it will be working from the very first run. Like, it compiles. That model, every other model by Google, I'm not a fan so far, but the Flash Thinking one, amazing work. Like, honestly, I want to see the secret sauce. I want to see the recipe for that model. I wish Google would release a paper on that model. Pretty sure they will never. But that one is huge. Yeah, Jade, I prefer the Flash Thinking one over the Pro. The Pro is very disappointing. Like, actually, I was waiting for the Pro, and that one is very disappointing. It doesn't produce the same quality. It takes a lot longer. It doesn't, like, again, I'm very surprised with how good was that quality and the Flash Thinking one. It doesn't make sense to me that it's that fast and that it works so well. What else? So in case we now have almost 6,000 people on this stream, so I just want to again reintroduce myself. I'm Ahmed Osman. I have this blog, and this is my Twitter account. In case you're interested in the next streams, I have built this 14 RTX 3090s in the basement of my house. Right now, the temperature outside is 23, and I don't have the heat on because my AI server is keeping the house warm. So that's good. I'm saving on gas. The thing has 14 RTX 3090s. It has 512 gigabytes of RAM, and today we are getting DeepSeek R-1. The 671 billion parameters model, quantized in integer 4, in 4 bits integer version, running with partial CPU offloading. Not really partial, like we're using 1 GPU and we're using the rest on the system RAM. I have documented a lot of things about this journey. I started my first blog post was back in September. It was only 8 GPUs back then. And I have noticed that people do not like to read long articles, but I think this is some of my best work. It's 14 minutes read if anyone is interested. And it goes through like agents, it goes through architectures and inference engines, talks about mixture of experts. It has a bunch of details about tensor parallelism and batch inference, quantizations, and what do they mean. Really good stuff. I'm not just trying to hide my writing, but like I put a lot of time into that one. And recently, funny enough, I wrote a blog post just last week. The context of it is that I was watching the Parisian streaming, and he was testing his 6 GPUs, tiny box, and and he was using llama.cpp. So I was like, I need to tell people to stop wasting their multi-GPU setups with llama.cpp because there's tensor parallelism and batch inference, and I talk a lot about inference engines in this one. Okay, this is taking a minute. I'm sorry, everyone. I really cannot do anything about it. Besides that, anyone has any questions? Like, I would love to. Actually, yeah, because I sent it to him asking if he's okay with me mentioning his name in it, and we had a conversation about it. So yeah, he read it, and he told me that it was good to have that put out there. Yes. I wouldn't mind if anyone wants to tweet at him and tell him that I just mentioned him in my stream. He needs to know that there's a new player in town. I really enjoy his streams, by the way. He puts good stuff out there. He's willing to like just sit down and try stuff. I actually like. I just decided, okay, I'm gonna sit down and like just talk and chill with people and do things in this AI server. Actually, while this is building, let's do something else. Let's get VLLM up and running. Is there interest in that? Like just how I use my AI server. And I'm gonna get my scratch pad moving. And so this way we can actually just get a model up and running. I use OpenWebUI a lot. And I don't know if you guys have ideas for things to run right now. I'm down. Just saying. I just don't have evaluation or benchmarking scripts ready, so hopefully that's for next time. But for now, let's just get VLLM up and running. All right, so funny enough, I have so many like aliases. Everything is an alias because honestly, it's very difficult to be running all of these things without just shortcuts. So like I even have this thing called CVD, and CVD, and this entire command is for exclamatory. But CVD, what does CVD do is which what CVD? Yeah, this thing, what it does is that it specifies which GPUs to run something on. Like we have this coda visible devices, and it just takes numbers, device numbers with commas in between them, so that if I'm running a model on two specific GPUs, I can say, okay, GPU 0 and GPU 1, then GPU 12 and GPU 13, if I'm just trying to like separate them for heat reasons or whatever. I'm not going to do that right now. This would be too much. Okay, I'm just going to do something really quick. Off screen. So what I'm going to do is that I'm going to show you guys how I run assemble model. Let's say let's do the DeepSeek R1 distill like from Qwen32, right? And I'm just not gonna show you guys the ABI key. I'm gonna enter that later. Oh shit! Damn it! My autocomplete. I didn't account for that one. But in short, it's pretty much VLLM serve model. The model name. I specify the tensor parallelism. Let me see if I can get this font increased. So I run a serve command with VLLM, specify the model, specify the tensor parallel size, which is run on 4 GPUs. How much of those 4 GPUs to run? So I always say 99% because I'm not running any user interfaces or any GUI or anything that would take memory space for the models themselves. I specify the max model length. So this is the context for the model itself. So the max for this stealth version of DeepSeek is 32,000. Disable custom all reduce. These are just warnings that I yeah, Jade, it's fine. Yeah, it's not that big of a deal. I specify the halt and the port and then the ABI key. So that's pretty much it. And then I also, so right now it's like loading up, it's loading up. In case anyone is wondering, it's like takes some time. The codegraphs usually, and I have this command that pretty much grabs everything, updates Open Web UI for me, and I build it. Then I do the same for the web interface, and we're just doing this while we're waiting for the code, the building llama.cpp to finish. Actually, I'm gonna do this real quick since we have time. As you can see, guys, Node takes forever to build. However, like Bison, I mean, I hate the dependencies that we have with Node. So many dependencies. Code is taking forever, but that's fine. Okay, almost home. This is just downloading an embedding model, by the way. Updating an embedding model. Interesting. It's hung up, so just curious. Let's get started. No, the system is fine, still running. My VTOB is telling me everything is good. Makes me wonder why this one is. I think it's a network hang up. So. Okay. So it's finished, and then I'm just gonna run it one more time. All right. And this is my usual setup. So and right now it's loading. It has the DeepSeek R-1 distilled Quen 32 billion. Sorry, this one. And let's ask it how many times in the world. You can see how fast this is in comparison, though. And this is not quantized. This is the full weights of the R1 distill from Quen 32 billion parameters that DeepSeek itself put out there. So again, this is way faster than what we have been seeing, right? You can even see I have the statistics here. The output was 750 tokens, 35 tokens per second. Did the whole thing from prompt evaluation to output in 21.13 seconds. And this is just, again, this is just DeepSeek. Like this is just the full weights. I'm pretty sure it would be even faster if I'm running like a quantization. Like if I'm running an EXL, it would be faster than this. In fact, let me load up. I have the same model in EXL2, 6-bit, 6.5 bits. And this is the 72 billion parameters Quen 2.5 instruct model. And it's one of my favorite models. So I'm gonna run it. I'm gonna load it up in. I'm gonna load it up in both EXL2 and full weights. The results for the full the 671 billion parameters big boy were really good. Offloaded the entire thing except for 13 gigabytes activated weights on the GPU. So we had one GPU being used, and the rest was offloaded to RAM. And for like 2,000 tokens, it was processing at like 2,000 tokens answer. It was processing at like producing 7 tokens per second. So that was pretty good. And right now, what we're doing is that we are building llama.cpp so that we can compare llama.cpp with this. Okay, I think that we have right now we're at 200 viewers. So what I'm going to do is that before I do the 72, the VLLM and XLlama on the 72 billion parameters model, I'm just going to rerun what we did with KTransformers so that people can see it. Okay. gang of line. We're gonna try it again, just to give people that just joined us an idea of how things have been, and then hopefully by then we can have llama.cpp done building. So this is offloading to the CPU, and you can see it's everyone can see here that it's offloading to only one GPU out of the 14 GPUs, from device 0 to device 13. And this is all PCIe 4, like when they're activated. You can see here it's 1 at 8x, like PCIe Gen 1, but that's because they are not active. But once they are active, they become Gen 4 at 8x for their speed. And it will offload 13 gigabytes to a single GPU, and then the rest will be offloaded to the CPU. So the system's RAM. These 13, okay, yeah, that's a good question. So I'm gonna show what, I'm sorry for repeating myself if anyone like has seen this before, but I have this thing in my basement. It's right now heating up my house. It's 14 RTX 3090s. It's literally underneath my feet, the floor below. And I have this blog where I document a lot of things. It's ahmedosman.com. And I started originally with 8 GPUs, 840, 8 3090s. And now we are at this level at this point with 14 of them. And the task for today is to get KTransformers newly optimized inference engine to work with DeepSeek R-1, the full 671 billion parameters model, and see if the numbers match, because here was they have said time to first token is 6 seconds for 500 tokens. So when the input 500, down from 53 seconds, it's 90. The prefill is 97 tokens per second from 10.31 for llama.cpp, and degenerates 13.69 tokens up from 4.51. So we're just gonna ask this thing, how many are in the fourth strawberry? And this is, again, all that we have is one like GPU being used for the activated parameters, and the rest is offloaded to my 512 gigabytes of RAM. It's only using really 300. It's only using like 385 gigabytes of that. And this is the speed of the. This is a quantized version of the model. This is the 4 bits quantization. It's 405 gigabytes, and it's running at a very good speed for me, given the fact that it's only like running on CPU. Did that answer your questions? And it finished thinking, and it counted, and it gave you the reasoning. Again, this is pretty consistent. Okay, so this actually makes me wonder if, yeah, because if I run the same prompt, but I decrease the number of max tokens output, then it would be faster. So I'm gonna rerun this. So as we can see, it has 21 tokens. The evaluation duration for it was 1.6 seconds, and it evaluated at a rate, like the prompt itself, it evaluated it at a rate of 12.7 seconds tokens per second, and then gave us produced 713 tokens, 90 seconds. Took 90 seconds to do that, was a 7.8 tokens per second. Now I copied the prompt, and I'm gonna change one thing in the run command for this chat script. I'm gonna change the max new tokens to only 1,000. And again, the whole evaluation, the output was 700 something tokens. So now this makes me wonder if actually the total number of tokens has an effect. Oh, llama.cpp actually finished building, so that's good. So we'll get back to that. We will get back to that. All right, and let's just, I'm gonna use the same prompt, exactly the same prompt, because I want this to be exact. excuse my debugging dog. Has to be here. This one is overthinking. This run is overthinking. Yeah, it didn't even finish. So I'm seeing different results, honestly, and it makes me wonder if it's just a runtime thing. I mean, I bet it's better than the llama.cpp one. So actually, while we're at it, let's go to that. Since llama.cpp finished building, thankfully, only took it like what, half an hour? On like yeah, took it 13 minutes 48 seconds to build something that shouldn't take this long on 64 cores and 128 threads. I want to keep a copy of this for later. And what we're going to do is that now we need to figure out how to. Oh, there's no Bison in this one. Now we need to figure out how to get llama.cpp to run. With this model. This is going to be an interesting one for me. Yeah, Jade, I agree with you on that. Yeah, so you're right. Jade is pointing out to the fact that the 700, like for 700 tokens, the rate was 7 something, 7.5 or something. I can't remember exactly. But for this run, it produced more tokens and the speed was faster. So this tells me that the max new tokens parameter has something, like that option that has something to do with this. Now let's do this. Let's get llama.cpp to work with this model. And I'm gonna grab the documentation from Ansluth for his dynamic R1 quantization. Yeah, Jade, you were talking about something else, but it just made me make a connection to something that was also true. You're right. Yeah, the last 70% of compiled were faster than the first 30% in total. Yeah, you're definitely right. So, Ansluth, they have released. No, but I don't want the distilled. I want the real one, please. Yep, the DeepSeek R-1. So they have released dynamic quantizations that are like 1 bit and 1.5 bits. And that's what I wanted to I'm not rebuilding this. I'm not rebuilding this. Please don't make me rebuild it. I think it's gonna work because honestly, I think I've built it with everything. So this is gonna be interesting to see. Okay. Yeah, this is was GPU offloading. This is what we need to do. Okay, so let's specify the model location. Okay, let's just try this. I'm not sure this is going to work actually from the first try, but yeah, Llama CLI is here. So we got that one. Okay, so I think I know why this might be a problematic. So it's not just the that it cannot find the location for the configuration. So I need to do something. I need to do this. I need to grab everything that is in here into this location. So what we're gonna do is that we're gonna copy everything. And we're gonna just grab everything within here. Okay, that's okay. That should make it work this time. Fingers crossed. I think this one here. And actually, the cache type option, I don't know why it doesn't like that one. Sorry. Now it's not liking threads. Found 14 coded devices. Oh, this thing is joking, isn't it? I'm going to do this. Dude, I'm trying to get the help. Yeah, this has threads. This has everything. So why is it not working? Just I'm gonna have something. Nope. Might have to do with caching. Was the shell that I'm using. Yeah, this time it only errored because not because of the options, but because of the model configuration, I bet. So this is something we need to. Okay, so I need to figure out how to do multiple files. I'm actually wondering. I don't know if anyone does pointing to one GGF make the other ones loaded. Let's try that. Yeah. Okay. And yeah, it split itself over all the GPUs. That's annoying. I'm actually gonna shut this down and start a new one with just specifying which code the device is visible, because I don't want it to be on all GPUs. Yeah, bar waste is like, why are you making all these GPUs run at the same time if they're pretty much just offloading a little bit on all of them? Like it's pretty much gonna be like using 1 GB or something from each GPU, and then running up the bar on all of them. But this makes me specify no, just use the first one and nothing else. Also, let's see if it's gonna work. Um, okay, so it's trying to use. Okay, let's do something. Again, I haven't played with llama.cpp in a while now, so I'm not sure how this is gonna go. But it had a problem that it was trying to allocate 49 gigabytes of GPUs, 49 gigabytes from VRAM, and that's why it crashed. Yeah. Um, but now it's actually offloading to both GPU and CPU. So as you can see here, it's now offloaded to 3 GPUs, and the rest are going into my CPU. Fails to create context for a model. Oh, man. Okay, I need to understand. There's got to be a way to specify. Yeah, he only specifies like, yeah, no, it should. Like here, it's 1 out of 3, and it should work. So why is it erroring out on us? Failed to allocate code as your buffer size. Yeah, why are you trying to allocate any more code? Let's give it to 1 more GPU and see. Actually, let's place it and give it 5 GPUs in total, because it's trying to use more GPUs despite the fact that supposedly number of GPU layers. Okay, I think I just need to understand more about these values. I might be wrong. Last time I used this was a long time ago. Oh, it's running, everyone. It's running. So it's using pretty much. Yeah, it just needed 1 more GPU. Create Flappy Bird game in Python. It's gonna start to think, and yeah, I shouldn't have asked that. I should have asked it to count the number of R's. I'm just gonna solve this, but now we know. I mean, it still gave us some input about 7.58 tokens per second, etc. Let's just do this from the top. She's just gonna make it 3. Cache like. Everyone, bear with me while I try to figure out these options, because I like to optimize my stuff. I don't. Okay, what if this is something I wanted to. I don't want to specify this. I wanted to just gather that from the model configuration itself. Set the number of threads to use for performance recommended to the value of number of CPU cores the system has. So just want to make sure index 7.3. Which it has 64 cores, but Yeah, 64 cores. That's right. So we're gonna just set this one to 64. What is no CNV? I'm gonna put this away. Let's Grail. I'm just gonna remove the things that I cannot find in the original documentation. I don't know if this is something that had to do with the way Ansleuth was recommending building the. Okay, how can I set the maximum number of GPU to layers? Actually, this is an important. If anyone here is familiar with llama.cpp, feel free to like jump in. Interesting. Somebody is asking about the specific model. Mhm. Okay, thanks, Jade. I'm actually gonna try that. You can create something to something bigger, 50, of course. Okay, so I'm assuming. Okay, let's do this. Let's try 50, and because I think we need to experiment with this until we find the right amount, and that's why this is one of those things that I really didn't like, right? When it comes to CPU offloading and llama.cpp, is that how can you control that? What we're gonna do is that, yes, 0.6 is good. We're gonna just try 50. It's shut in the dark, and then we're gonna go up as we go. And for now, I'm just gonna set it to 1024 so that we're limiting the context. I need to figure out what's the problem. What is this thing? See, it's set down. See default. Okay, I actually don't want to set the C. Yeah, I don't want to set this. This would be really cool for now. And let's see how this plays out. And again, I'm like giving it all full access to all my GPUs. Just take over, please. Oof. Crashed. Of course it did. Okay. So 50 is a lot. Now, divide and conquer. 25. All right, Jade. Thanks for hanging out with us, man. I haven't used llama.cpp in a long time. Hopefully this works. Because I'm actually interested in seeing it working. Like, okay, so it's offloaded a lot. Yeah, it's offloading. Well, I don't think it's using my GPUs to their full potential. So we're gonna stop this. Because I think there's a lot of waste. So run, it's not worth it. And before I continue any further, I'm gonna change something real quick. I am going to bar limit these GPUs because now you're down to 280 from 420 because I don't think that we need it to work, at its hardest. That's not going to be beneficial in any way. So here's what we're going to do. We are going to try with maybe 40 layers. And I am going to disappear for 1 minute and I will be right back. And I am back. So clearly that didn't work. Let's lower it to 35. Okay. Unfortunately, there's no good way to calculate this. At least I don't remember finding any. We just looked at GitHub issue on their repo, and they closed it as not planned because, again, this is one of those things that are very annoying. That's why it's like, just do a full GPU offloading, or be okay with, you know, not a perfect floating with llama.cpp. And okay, good. They're using the GPUs. And unfortunately, no. Now to maybe I'll do 32. Let's just try 32. I have a good feeling about 32. And it's loading a lot to the GPUs. Something you always like to see when you have these many GPUs. And again, failed. By 28. Originally it worked with 25, so let's see 28. Nice. Yeah, it's using a lot of my GPUs, so I guess this is something I just need to figure out later. But from a first look, it seems a lot slower. Okay, that actually, it needed me to hit enter for some reason, so now it's working. Okay, and by the way, it's using my GPUs. You can see a jump in the power usage. So yeah, now let's just see the numbers. Okay, it's thinking about how many R's are in strawberry. Okay. I think it's overthinking, by the way. And in order for this to be a fair comparison, I think I need to also just offload everything to the CPU except for one GPU. Yeah, I think that's after this run, I just want to get the numbers by offloading to both the GPU and the CPU and see from there. Okay, so we got some numbers. Okay, so actually, this didn't even finish. It didn't get to the full output, which we have seen before, but it's also like was offloading a huge amount to the GPU. Like I'm gonna say like 14 gigabytes multiplied by 14. You're talking about almost 200 gigabytes, right? Yeah, almost 200. 200 gigabytes being offloaded to the GPU, and the rest 200 plus GPUs, like maybe 210 gigabytes, uploaded to the CPU, to the RAMs. You got like the evaluation time for 1,000 tokens were 6.75 tokens per second. We were getting 8 with just one GPU and the rest uploaded to the CPU. We were getting even 13 earlier when I need to go back and rerun that benchmark, by the way. But we were getting 13 tokens per second. So this is not ideal at all. So now what I'm going to do is, and we already know that this is working. I'm going to specify 0, just one GPU. I'm going to give it all the threads, and I'm going to like maybe do 64, 28 gives you 14 multiplied 14 by 15. So I need to multiply 28 by 0.1. Okay, so let's give it a 4. Yeah, let's give it a 4. And then same for everything else. Because what I'm trying to do here is limit it to one GPU, specify the model, tell it to use the 64 sockets, the 64 cores that I have in my system, only offload 4 layers. 4 layers are going to amount to about 14 gigabytes. I just did the quick napkin math. The temperature is 0.6 because that's what DeepSeek recommends. Context size is only 1,000 tokens, 1,024, and then the prompt. Let's try this. It's going to be limited to 1 by default because of the environment variable. Oh, failed out of memory. What? Yeah, that's my napkin. Okay, so it's not even like, it's not proportional. Like I tried to like think about it proportionally, but that doesn't work. Let's try this. I was gonna give it one layer. Because really I want to see it on the CPU just like the other, just like KTransformers, because this tells me that these people's numbers are actually very on, like, spot on. I mean, I didn't think that they were lying or anything, but I just wanted to see it for myself. And like, kudos, they did a huge, they did a huge thing. Even if it's optimized for one model, we have to think about this in a way that, okay, so just before I continue what you're saying, yeah, so one layer is 13 gigabytes, perfect for me. In this case, this is very similar to what we had on the other side, and the rest is offloaded to the RAM. Now I'm going to hit enter so that it starts. Okay, and this is now running offloaded on the CPU. So this speed is CPU and RAM speed. Again, what I was trying to say was that we need to think about optimizations, and as in, okay, this is possible for one model. So what's possible for, as people continue further this, like down this road, can you optimize more for the models? Can you optimize the architectures to work in a better way on the CPUs? This is amazing. In my opinion, like, there's a lot to explore here because things are not ideal at this point, but I'm very happy with what I'm seeing today. And I have a feeling that it's not even gonna finish, because the context. So I might have to rerun it. But that's fine. Stop overthinking, DeepSeek. Stop. Yeah, this thing, I don't know what's going on with it, but it also like overthinks a lot more. Okay, so ultimately it came to the conclusion, right? I mean, there's only I can also say that it had the context window, but ultimately for 1,000 tokens, it's 4.45 seconds, 4.45 tokens per second. What they said is that it's 4.51 tokens per second. I mean, there's going to be like a negligible amount, like differences that are just from different systems, right? Like just tiny factors that can change these uh, numbers in a slight way, but it matches. It matches. Now, in I'm going to run this one more time. Uh, just want to make sure that I got this right. Yes, 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 yes. Prompt file, and this one is gonna be way faster. And I want to make sure that I'm getting the right. Like I want it to be exact, so I'm gonna get the same exact prompt. Now this one is gonna offload almost everything except for one layer. The activation layer, about 14 gigabytes, it's going to be offloaded to GPU number 0. All right. So we are now. So again, just for those who are curious, oh, actually, it's just one layer, and it's like pretty much just uploading the activation layer. So KTransformers probably part of the optimization is that they are picking up the activation layer and making sure that that goes into the GPU. So that's pretty smart. Now, the second thing is that, so just again, I'm running here DeepSeek 671 billion parameters, 4-bit quantized. It's currently residing on my SSD at a size of 440 gigabytes, and I have 13 gigabytes of those 404 gigabytes on the GPU, and the rest are loaded on the system memory, right, on the RAMs. And I'm going to ask it how many R's. And we just tried with llama.cpp, and it was giving us 4.45 tokens per second to answer that question. Now we're going to ask it with KTransformers. this is faster than llama.cpp. Like everyone can see that, right? So again, nice, very nice optimization, and we're gonna see the evaluation numbers in a second. But the fact that I can run this model at this free, like it's faster than, or maybe it's matching my reading speed. That's pretty good. The output speed is pretty good, and the fact that I don't have to think about which layers to offload, like with llama.cpp, the fact that it's only using one GPU, this means that I can use the GPU, by the way, for like maybe an embedding model or something, and then use the 13 other models for other stuff. So this gives me like an extra model that I can use at a good speed. Yeah. Okay, so it didn't really finish. And it's probably because it's the context, but again, ultimately, it's like thinking about it, coming to the answer is 3, and it took it like the evaluation rate was, and actually it might be better if we do this. It might be better if we can just see it all together. So for the KTransformers, 21 tokens in the prompt. Took it 1.6 seconds to finish that, which is 13 tokens per second, right? The evaluation, the context that I allowed it is 1,000 tokens, took 2 minutes. This is pretty consistent with another run we did like an hour ago. And it pretty much was doing like generating at a rate of 8.4 tokens per second. Now, we look at llama.cpp with 14 GPUs, about 14 GB offloaded to each GPU. So 200 gigabytes offloaded to 14 GPUs, and then 210 gigabytes offloaded to the CPU. And we get the following. It took it sampling time, I'm not sure what's that, but what I know is that the evaluation time for the prompt was 16 tokens, or like 1 token, pretty much 1 token per second. So pretty much like 0.8. That's it. We went up from 0.8 tokens per second for the prompt eval to 13 tokens per second, right? 4 points like that. The tokens that we got, 4.45 tokens per second in comparison to 8.3. That's doubling. So I say that's pretty good. And honestly, I want to rerun this, but I want to give it more context because I want to see it finishing the answer. Actually, if you guys bear with me, I just want to read a couple of things. The prompt file. When you see chat, then press enter to load. Okay, so honestly, we don't even need the prompt file, so I'm just gonna remove this. And I just want to quickly understand what is CPU inference, like that number. Okay, so adjust it slightly lower to your action number of cores. So actually, I think we can get even more out of this if we do something like 64, because I have 64 cores. hours. And I'm gonna make it 2048. Yeah, that's that. Nice. So again, just one layer, one GPU. And now I'm really wondering how this is going to be different, given the fact that I just told it that it has double the amount of core. It's a little faster, but could be just the beginning. Mm-hmm. Maybe the correct answer is true. No, sir. No, DeepSeek. Focus, focus. Bloody, you can do better than that. It's not 2 hours. control over things more than anything I've ever seen. Just wow, giving it more CPU cores doesn't make it smarter. Okay, I think it's. Why are you thinking about Blueberry right now? I haven't seen it go through this conversation before, by the way. That's why it's funny for me. Oh, the things we spend our computational power on and our money on the electricity for. Okay, yes, that's 3 R's, so the answer is 3. I'm very proud of you, DeepSeek. Okay, so again, evaluation-wise, the prompt 21 tokens, 13. Again, I didn't expect this number to change. 13 tokens per second in comparison to what? In comparison to 0.81 tokens per second, and this one was 200 gigabytes floated on GPU. So that's no, this run it was pretty much the same, and this run was actually just one layer on the GPU. So same GPU distribution wise, and it was 4.45 tokens per second for the output. Right? This one 1972 tokens, so almost 2,000 tokens generated, and the rate is 7.63 tokens per second. That's pretty consistent from what we have seen. I would say that, yeah, these people did something. And also the increase in number of threads or number of cores for use by KTransformers doesn't add much. It really doesn't help that much. So maybe the optimization for AMX based again, I said like AMX 524 something like that. So and it's for a different platform basically than what I have for a CPU right now. So it doesn't work with my server. So that's fine. But ultimately, these numbers, yeah, we didn't go up to 13.69. Didn't expect that because they are optimized for specific Intel instruction set. But it jumped up it. We're pretty much doubled on the output wise, and the time to first token, like absolutely such a high like upgrade. Like we went from 0.81 tokens to per second, like less than 1 token per second to 13 tokens per second. Huge. So goes to the KTransformers team, the KTransformers inference engine team. They did something really good to showcase that you can optimize CPU inference. You can get such a huge model like R-1, 671 billion parameters uploaded. Like yes, integer 4, like 4 bits, integer quantized, but you can do that and you can upload it to the CPU, except for the activation layer, and you can get a very good and acceptable token generation rate and pretty much like reading speed. Again, this will allow me for those newcomers into the picture, into the stream, my name is Ahmed. I have this thing downstairs, literally below my feet right now. It's 23 degrees Fahrenheit outside, and this thing is keeping my base heated up. It has 14 RTX 3090s. So this HGBU is 24 gigabytes of VRAM. I have a total of 336 gigabytes of VRAM, and plus 512 gigabytes of RAM, and a good processor that comes with it. And I have blogged a lot. This is how this setup was back in July to September. It had only 8 GBs. I blog a lot. I write articles about different things, including this one is pretty long, and honestly, it was kind of disappointing not to get so many, people reading it. But it was very good on inference engines, architectures, models, mixture of experts, batch inference, stuff like that. And most recently, I just published, funny enough, a blog post about stopping and not wasting your multiple GPU setups with llama.cpp and using VLLM or XLlama for tensor parallelism and batch inference. So that's your intro to me. Besides that, the main reason for me to stream today was to pretty much get this up and running, get DeepSeek R-1, the full model, running on this thing without the necessity of GPUs. I was talking with a good friend of mine yesterday. He's trying to build an AI server, and I told him to focus on getting a good AMD Epyc 9000 CPU, DDR5 RAMs, a terabyte or two, and make sure that you have a lot of PCIe lanes. Try to get it PCIe 5 with MCIO, and so that you can connect it with SlimSAS or MCIO cables right away. You have to consider things like redrivers and retimers, because there's signal loss and noise that comes. One second. So when you're running things with like a Razer, you will have, as you can see, I'm not using the wobbly cables to connect these GPUs. And the motherboard itself, like right here, like you can see that there's like cards inserted in the PCIe lanes, and then connected with SlimSAS cable, and then the GPUs themselves down here, right around this area, you can see like an adapter. So it's like a bridge, but this bridge isn't just like a cheap connection, like a cheap, like this Luby thing that you can use like the regular razors. These are actually drivers and retimers to remove any noise, because you have so much hardware in there, so you will have a lot of noise around these signals. So it's important for them to be cleared out. Otherwise, your system will crash. So if you're trying to build something like this, actually hit me up. I'm very interested in hardware. I can help a little bit, but that's I think, unless anyone has an idea or questions for what to do. I was originally thinking of doing stuff with VLLM and like continuing that journey we had at some point with VLLM, and we turned on my OpenWeb UI. We loaded VLLM and loaded the DeepSeek R-1. Actually, since we have some new people, let's just do this one real quick. And unless I get questions afterwards, or ideas for things to do, I'm gonna call it after that. So So right now I'm using VLLM. Actually, this is gonna fail. Yeah, because I didn't specify the GPUs, and I load it up. Yeah, it was gonna fail. I knew it. It's because I didn't specify with code invisible devices which GPUs, and it's starting with 0, trying to load up the model, but then it's met with something occupying that GPU. So let's try again. All right, I'm gonna change. Sorry, I just showed an API key. Yeah, I'm gonna change it afterwards, but not a biggie. So so what's happening right now is that this is VLLM. This is the most production-ready inference engine out there. It supports tensor parallels, which allows for layers to be distributed among GPUs and for calculations to take place at different layers and different GPUs at the same time, and then aggregated together at the very end, which allows for batch inference or batch requests. So, in one of my blogs, and specifically this blog, I showcase how I ran 50 requests with VLLM. And by the way, this is all like given the recent updates and optimizations done in VLLM, I'm pretty sure I will get better results. But just for an idea, I ran 50 requests. Each request had almost 2,000 tokens in its context, and then 2 minutes and 29 seconds later, I had 50 responses completed with pretty much 1,500 tokens for each request. So nothing would compare to this with what we have been showcasing, but I just wanted to give an idea. And I go in depth about this in this blog post if anyone is curious. The link to my blog is on my Twitter profile. Anyway, back to this. VLLM should be done. Yep, VLLM is up and running. And now let's just showcase real quick. No. 1 second, everyone, please. Yep. So we are gonna ask the same question. How many hours? This is the DeepSeek R-1, but the distilled. This is the distilled version with Quinn 32 billion parameters, and it is currently occupying 4 GPUs with 22 gigabytes per GPU. Okay. And it's occupying that amount. This is just one request, but let's say I'm gonna run this. But let's say I want to give people access to this website. I'm pretty sure I can be serving so many people from just those 4 GPUs, and you can see how fast this is. This is full GPU offloading. This is the other side of things, right? And then you get, okay, so generated, I have statistics up here, 750 tokens in total. Took 21 seconds to get to the answer, and it's 35 tokens per second. That's in comparison to the full model being 7 tokens per second. There are some optimizations. I don't know which model I have my OpenWeb UI optimized for right now, but there are a lot of settings that you can play around with that can make this a little bit faster. If you add something called drafting model, or yeah, they call it drafting model. there's a second name to it, but I can't remember it right now. If you add a drafting model, it will increase the speed by a lot. It can make this go up to like 50 tokens per second. And actually, I'm going to do what I earlier said I was going to do, just because I think it's fun. And what we're going to do is that we are going to load the same model one time with VLLM, and it's full quantity, it's in its full weights, and another time with Llama v2 quantized to 6.5 bits. And the first time when we're running it on like with VLLM, it's gonna use 8 GPUs, but the second time it's gonna use 4 GPUs because that's how how efficient quantization makes things. And we're gonna take a look at speed and stuff. So this is gonna be a quick demo. Okay, so VLLM. Bear with me, everyone, just 1 second, because I'm trying to get the command for the specific model from my notes. Yep, here it is. And in case anyone is wondering, this is the command I'm running. It's VLLM. This is what I'm going to be running. VLLM serve. It's basically saying start an endpoint for this was specifically Quinn, the Quinn profile, the Quinn 2.5, 72 billion parameters instruct model. Tensor parallelism size is 8 GPUs, use 0.99999% of the GPUs. Max model length is pretty much how many tokens can be in memory at the same time. I don't remember. I haven't run this model in quite some time, so I don't remember if this is gonna crash or not, but we'll figure out. Disable custom all reduce. You get a bunch of warnings because I'm not using like a production, like a commercial grade GPUs. So I just disable these warnings and then just setting up the port, the API key, blah, blah, blah. So just wanted to show everyone the command real quick. And then I'm gonna run it. And now it's loading up. Now you can see here in 1 second that it's gonna, like, already you can see the devices from 0 to, yep, here are. It's using all these GPUs. So it's using from device 0 till device 7, pretty much. And this is the full weights. This is unquantized. This is just what Alibaba people uploaded onto Hugging Face. All right, we're almost there. Of course, it's going to take a lot, but pretty much all AGVs are up. And then go the graphs, blah, blah, blah. All the goodies. And we are a go. Yeah, good. Now, honestly, asking this model to specifically shoot. One second, everyone. I just need to fix something real quick. I need to do that in the admin page, so I hope you guys understand that everything is fine. All right. So now this model is up and running. Okay. And we can ask, that's funny. Everyone, you didn't see anything? I didn't just paste an API key into the chat or anything. Okay. So again, this is pre-thinking LLMs. It's so confident in itself, right? It's like the word strawberry contains 2 R's. No, excuse me, it doesn't. But I understand. But let's make it do something more difficult for us. Explain to me how insert parallelist works. And it will go on because in this I have given it pretty much like 118,000 max model lengths. The context can be like, enjoy yourself, whatever you need. So this is, again, fully GPU offloaded, right? Running on only 8 RTX 3090s. And it's like, I usually cannot keep up. I have to like wait for it. That's why like I usually ask it something and I go do something and come back to it, because you can't keep up with what the models is outputting when you're fully offloaded to GPUs. All right. And it explained everything for us. And then we can take a look here. 1,600 tokens, 50 seconds, 31.87 tokens per second. I would say that's pretty good, right? Now, this is VLLM. I want to take a quick look now. Oh, this is the wrong one. I don't know what's going on. 1 second, everyone. Okay, it crashed for some reason. I don't know why, but it did crash. We'll figure that. I will figure that out later. It probably has to do with the max model length. But for the meantime, let's move and like. I'm just trying to give an idea, right? Offloading to 4 GPUs or 8 GPUs, pretty much with tensor parallel, is pretty much giving us 30-something tokens per second across different models, right? Now let's go try to run this very same model, except quantized using XLlama v2. And I need to remember my XLlama commands. So, well, not really remember, more look them up. Bear with me, everyone. Nope. And here's what we're gonna do. Just had a bunch of aliases for all of this, so I'm gonna try to get really quick. And I have a command for Tabby. Tabby is pretty much the API server for Xllama. So Xllama v2 is just a quantization engine. Like it's just an inference engine with like a quantization I don't want to say infrastructure, but like a quantization algorithm. Okay. Then you have Tabby API, and that's your serving. That's your endpoints side of things. So, and Tabby usually requires Xllama. So I'm just trying to give a general overview of what I'm doing. Now I have a configuration.yaml file for that I'm going to show, but I will need to do something really quick with it. Yep. Okay, so that's good. So this file, it has network, disable authentication. Always never disable authentication, guys. That's how you get hacked. Then I like plugin stuff just because it allows me to debug more as I go. Where are my models, etc. Max sequence length. I'm telling it it's the full 128,000 tokens, right? Tensor parallelism, yes. This can be ignored, by the way. No, this is me saying actually use the full amount of VRAM available there for every GPU that you're trying to run on, right? The cache mode, I have it in N4. This saves memory by a lot. The chunks, this is how small or big the context size is that gets processed at the time. And usually it becomes faster as you increase this, but also it uses more VRAM. So I usually optimize for using the full amount of VRAM that I have, using the full amount of VRAM I have, but also making sure that I'm not exceeding that number. And if I have the resources, I have the resources pretty much. So I do this because this fills up my GPUs and also allows me to run without crashing. Now, this is where it gets interesting. I don't think I have a draft model for this one. I have a draft model for another model that I will run after this, but I just want to demo this first. Draft model is pretty much like something that tells you what the tokens are, and the smaller it is, the faster your input can be processed, and this increases the speed by a lot. And not just your input, it's also the evaluation. It's also the output that you're receiving at the end. It's using that as a layer that is just specific to tokens, just specific to the letters and their numeric representation in the memory. You have embeddings, you have a bunch of other things. These are just developer options. I already have all of this optimized. And I don't need to do anything else with this. And then I usually have like CVD, and I specify which code visible devices. CVD is just a shortcut. It's a function that I made, and this function which CVD, it shows you just a bash function. This bash function, what it does is setting code available devices environment variables so that I can specify which GPUs are being used at any given time. So I'm not doing that because I'm not trying to load several models at the same time, but I have aliases to Q72, that's Tabby, Quen72, and then it just translates to this, and now it's being loaded. And as we're looking at this is only using 4 GPUs. Again, same model, same everything. And no, I want to show you. I want to show something else. And again, just to be clear, just 1 second, everyone. Okay, where do I specify the model? Oh my god. Yeah, here it is. But I'm trying to actually figure out something else. So let's take a quick look. Right, thank you. What I'm trying to do is no, yeah, sure. Okay. Now I can see. I'm just trying to figure out what is the quantization of this model. Yeah. Interesting. I'm pretty sure it was the 6.5 bits. So let's just assume that. Now the model is loaded. It's using pretty much, like, you can see a huge amount of space left. Like, it's only using 20 gigabytes out of 24 gigabytes per GPU. And what we can do right now is, I'm just going to do this real quick. Start a new conversation. And again, remember everyone, we asked it this question, explain to me how tensor parallels works. It gave us 1600 tokens, 32 tokens per second, and answered in 50 seconds. Now, I need to refresh this. Yeah, I know. I knew it. Once again, I'm fixing something with API keys again, and I'm sorry about that. But then we can go here. I'm just changing something real quick. All right. Now we got the model back up and running, and we are going to ask it, explain to me how tensor parallels work. And it's using 4 GPUs. Again, you can see the power up so much. It's like 268 out of 280. And you can see the speed. And this is only on 4 GPUs. Again, same as the last same model except quantized EXL, Llama v2, EXL2 quantization. I think 6.5 bits per weight, and I think it's pretty much giving the same answer. Like types of tensor parallelism, basic concept, key concepts, how tensor parallelism works. Might be a little different. Implementation steps. Okay, I would say kind of similar, not exactly the same, and I don't know why it didn't show the token statistics. 1 second, everyone, please. Settings, models. Okay, I think the API tabby just doesn't support it, but we can see the same numbers here. Pretty much 1351. The generation speed is 25 tokens per second, and generated in total 1351. So again, VLLM was faster, had more output, and like 31.87 tokens per second in comparison to Llama doing 21.25. So honestly, this is something that I need to further look into. But I'm saving 4 GPUs, so I don't mind. VLLM is very optimized. VLLM is it's production ready. It's like what huge companies use nowadays. So no surprise there. The one thing I actually want to show fast before calling it, and I think I need to go take a walk. But this has been fun. Honestly, I'm definitely doing this again. So if anyone is, if anyone liked hanging out today, please just stay tuned for the next thing. Now let's shut this down, and I'm gonna okay, yeah. This is the so this is the quencoder 2.5 to 32 billion parameters coder, and I have this one. I actually think that this is the one that I can show this on. Yeah. This one is 6 bits per weight, so it's quantized into 6 bits, and I'm using with it. I'm using this as a drafting model. It's the 1.5 billion parameters coding model, and 4 bits quantization. Again, both of them are EXL2. Now, different cache mode, I honestly optimize this differently based on what I'm doing. And yeah, the drafting model, it's this one. And this is going to run on only 2 GPUs. And I even have like the Stella English 1.5 billion parameters embedding model. It's one of the best out there, and it helps me embed my code and like my projects so that it's easier to retrieve contextual related snippets and documentation. Now let's get this one running. Yeah, here. Yeah, this one is going to run the coder for us. Okay, so now it's loaded. And here's what I can do. The equalization. Interesting. Okay, figured it out. So this is again when 2.5 coders, there's 2 billion parameters in struct, quantized, and it's only running on 2 GBs, right? So this is very optimal. And I can tell it to implement this is my canvas right there. But unfortunately, not really much, which is annoying me because sometimes it does better. But here's the thing. Now it generated 1100 tokens, and it did that. It did that in six. I'm sorry. Yeah, it did that at a rate of 60 tokens per second. I take away that drafting model, this is probably going to go down to 40, 30, something like that. I think I actually have the same model in VLLM, so I might show it to you guys. But I actually want this thing to let me implement a simple and functional basketball web basketball game. Yeah. Okay. It's not exactly functional because and just before it does that, I just want to show again. Yeah, the context. It generated new, like almost 1,000 new tokens. It already had like 1,759 tokens in context, and it processed that at 63 tokens per second. Sorry, everyone. Just okay. I can't tell exactly, and honestly, I know that's probably the JavaScript, and I have something in my system that doesn't allow JavaScript to run in this thing just for security reasons. But I'm happy. I think it generated something. Now again, it had this cached. The context was like almost 1,600 tokens cached. The context was 1,600. In total, 52 tokens generated in this conversation in 53 seconds. The last rate was 65 tokens per second for the latest response. So these are good numbers. However, just the final thing we do today before a quick recap and I go make myself something to eat, is that let's run the VLLM version of this same model to just look at the difference. I think the original model, like the full weight of this model, requires 4 GPUs, and I think it's a lot slower. Actually, the drafting model does a huge thing. Okay, yep, okay, I got it. And okay, so it's loading up, and while it's doing that, I'm just gonna quickly actually just gonna wait on it for a minute. And this one is pretty much, occupying 4 GPUs as expected. These are full weights, no drafting model, and we'll see how it does. Yep, that was quicker than I thought. And let's actually ask it the same thing. And see how it does. Also, VLLM just released like their 0.7 version of their inference engine, and it has a lot of optimizations. You were talking about it as if it's like, a massive release, and apparently like they optimize things for like double and triple the amount of tokens and stuff like that when it comes to generation and like processing and time to first token. So I wouldn't be surprised. I mean, yeah, that's without the drafting model, 4 GPUs again, 1,073 tokens, 36 tokens per second, in comparison to what we saw earlier, which was pretty much like 60, 65 tokens per second for the quantized model that was residing on 2 GPUs, offloaded on 2 GPUs, and at and had a drafting model. Now it's again, this is not working, which I might attribute to my security paranoia, not allowing code execution and stuff. But let's see if it's gonna do any difference. To ask it nicely to improve it. Okay. Yeah, it's probably has to do with the script not being in action. And again, version one, like it's very similar. Version two is the weird one. Version two, I mean, not that much of a change. Now let's look at the tokens. Yeah, 35 consistent, 1,000 tokens, 35 tokens per second. Took it 30 seconds or so. So consistent, and yeah, 4 GPUs in this one. Besides that, anyone has any questions or want to do anything while I'm still live? You know, I'm down for running cool prompts. And I think it would be a good way to end this stream was just a quick run of, because we have 7,100 plus viewers right now. So what I want to do is that I'm going to do a quick recap, but I'm also going to run the KTransformers with the DeepSeek R-1. And to those of you who are new here and like just started, just joined, I have this thing. It's running downstairs, literally under my feet. It's 14 GPUs, 14 RTX 3090s. It has 336 GPUs. 300. Oh, I wish I had 336 GBs. 336 gigabytes of VRAM and 512 gigabytes of memory, DDR4, and it's running an Epyc 7713 CPU. I have a blog post that I posted this a lot on Reddit. I like the local llama subreddit, but I started from this. It was originally 8 GPUs server, and I blog post a lot. I have very long articles on inference engines, architectures, MOEs, mixture of experts, stuff like that, quantization, tensor parallelism, and batch inference. And just most recently, I had a blog post that was titled "Stop Wasting Your Multi-GPU Setups with llama.cpp." Funny enough, we used llama.cpp today, and KTransformer kind of uses llama.cpp under the hood too. But the thing that the people at KTransformers did and were amazing is that just gonna get out of all of these just because I feel like I have too many things open. But what was really good about this release by KTransformers team is that it allowed for almost full CPU offloading with only 13 gigabytes. With only 13 gigabytes activation weights being offloaded to a single GPU, and the rest can be offloaded to the CPU and RAM. And when you do that, as we have seen in the stream earlier, you get some really good acceptable results for running the full 671 billion parameters DeepSeek R1 quantized in 4 bits integer. So that quantized size is actually 404 gigabytes. That's how much it's taking on my SSD. And we load up 13 gigabytes of that on one GPU, and the rest goes onto the system RAM. So that's a quick recap. We tested it with llama.cpp, and the numbers, I'm going to come back to these numbers later, but just quickly, I'm going to run this one more time before I call it tonight. So the command to run it is straightforward. It's running Python 3.11 that has a virtual environment with their local chat file, specifying the model path, which has the configuration, like the config.json file and the tokenizer, and specifying the GGUF, the quantized 4 bits integer GGF files, and then giving it a prompt file, which is not necessary, as I have come to learn, and specifying CPU inference, how many threads. We tried it with my CPU has 64 cores and 128 threads. We tried it with 33 cores and 64 cores, and honestly, they make a difference. So I'm just gonna save my CPU some useless hassle. We specified the max new tokens to be 1,000. I'm gonna make it 1,200 just for this run, maybe even 2,048, just so that you can like finish the run. And if we get anywhere between 7 to 9 tokens per second, it will pretty much consistent with what we have seen. We will go from there, do a quick comparison, and then I'm just gonna go and do things with my life. Quickly, I need to remember. Yep, I'm just gonna start clean slate. CD KTransformers, and from there, okay, that's just then disactivated my virtual environment for me, and then I'm gonna run the command that I just explained. This in turns is gonna fill about 13 gigabyte on this GPU on device O, device 0. Yeah, and right now it offloaded a part of itself onto the GPU, as we see here, and it's being like the rest is going to go into the system RAM. As we can see here, yeah, here it is. It's pretty much right now 82, 90 gigabytes, 100, 101, 108 gigabytes. This is being offloaded to the CPU as we talk. At the end, this should be like 305, something like that. Which tells me, by the way, like I'm actually gonna play with this, and I might get online later tomorrow or something to showcase a higher quantized version of this, and maybe try to see if I can get it get partial offloading to the GPU more than just that's 13 gigabytes onto the GPU, and see if we can get any more better results, better performance. So yeah, it's offloading here. Right now it's taking 275 gigabytes in the system memory and the RAM, and 11, it's going to be 13 very soon. $12, 342. It's going to go up to like 375. So we'll be using 375 gigabytes or something like that of my RAM, and it will be using about 13 gigabytes of the GPU. Yep. So again, yeah, 12.933 megabytes, so it's almost 13 gigabytes of VRAM, and it's ready. Yep, that's what I was looking for. And again, it's running 377 gigabytes in the system memory. So, and the RAM, that tells me that a total of like 390 gigabytes are being used between the GPU and the CPU. And I have 512 gigabytes of system RAM plus 336 gigabytes of VRAM. I think I can get the higher quality, maybe the 6-bit quantization running, but that's for later. I might actually do a stream later. So yeah, I'm definitely gonna do a stream later. So if anyone is interested in that, just keep an eye on my profile. I post a lot on Twitter. Now let's get this thing. I'm just trying to get a specific prompt because I want to compare it later to the, yep, this is the one. So again, only 13, and the rest is on their own. And now we're going to ask it, how many R's are in the word strawberry? Think time to first token, pretty impressive. This is printing at reading speed. That's very good for a 671 billion parameters model, pretty much offloaded to on a 7,000 Epyc platform setup. Like, this is impressive. I'm gonna make the font bigger. I'm sorry, I should have done that from the beginning. And it's thinking. Okay, third position. Yep, 3 R's. It's getting it. It's getting it. And this is not a distilled version or anything like that. We just did a bunch of distilled stuff and other models earlier with VLLM and XLlama. This is the full. This is the full 671 billion parameters. It blows my mind that I actually can run this thing at home. But let me count again. He is a professional, or it is a professional overthinker. So. Let me look up the spelling in my mind, because it's asking itself if maybe in the actual spelling there is only 2 R's. No. So now it's finished with its thinking process. Think tag is over. All right. So that was actually pretty good. Now we come to the evaluation real quick. What we have here is that 21 tokens in the prompt. Yes. The prompt evaluation duration, it's like how long it took to evaluate that, is 1.84 seconds. And the rate is 11.3 seconds tokens per second. right? 11.3 tokens per second. Pretty good. In total, it produced 1,817 tokens. Took it 237 seconds to tell us that Strawberry has, in fact, 3 Rs. Thank you so much. And it did that at a rate of 7.66 tokens per second. So, yeah, that's pretty good. Now, we take this and we compare it with this run. We ran this, and like I'm just going to show this quickly. We used llama CLI, we used the llama.cpp, specified the model, specified the GGFs, gave it the threads, offloaded only one layer, so that's 13 gigabytes too, set up everything the same way, and leave the sampling alone. This doesn't matter, but what we care about is the prompt evaluation time. It took it like it was doing it like to just before like time to first token. It took it this number of seconds multiplied by the number of tokens. So 16 tokens by this, so about 12 seconds before it was able to do anything. The other one did it in 1.7, 1.8 seconds. This one, and the rate was 11.3 tokens per second. Llama.cpp 0.81 tokens, 0.8 tokens per second. And then it generated 1,023 tokens, and it was at a rate of 4.45 tokens per second. We're up to 7.66 tokens per second with the KTransformers optimized inference engine for DeepSeek R-1, the 671 billion parameters. And these, in fact, by the way, we did a lot in this stream, so like there's a lot of like if you missed it, go back and rewatch. It's a fun one. But the most important thing, and I'm trying to get to it here, is that they benchmarked, and in their benchmarks were showing that llama.cpp was doing 4.51 tokens per second in terms of generation, and took it 53 seconds to actually start after a 500 tokens prompt. Now, with KTransformers, it took only 6 seconds, and it was generating at 13.69 tokens per second. And again, there's a difference. The main difference between the 13.69 to the 7.66 that I have is that they are more optimized for specific Intel instruction that allows for an AXM what's called specific selection of them. I have it here. Sorry, I talked about it earlier. Yeah, optimized for AMX MOE kernel. So it's optimized for mixture of engines, of mixture of experts models, in a specific way that only the 9000 Epyc CPU processors and Intel processors have that. I'm running a 7000 Epyc CPU, so I didn't expect that. However, I'm way happier using this than using llama.cpp when I am trying to run DeepSeek R1. Pretty much this is it. I've been doing this for almost 6 hours, so it's about time for me to actually go eat something and start working on projects. But I hope you guys enjoyed this stream. Please, feel free to connect with me on any of the social platforms. I have a website, it's ahmedosman.com. My Twitter profile is available, and if you have any questions, feel free to hit me up. Yeah, it's been fun, and I hope you guys enjoyed this live stream. Let me know if you have any ideas for something you want me to stream or do next. I'm hoping I can get this running with more offloading on the GPU side. So if I can use the 336 gigabytes I have of VRAM and offload a bigger model maybe to the CPU, I can have, or maybe this same one, just offload a lot of it to the GPU and the rest to the CPU, I can have some more optimal performance. Anyway, yeah, just hit me up. Let me know what you think. Send me tweets, whatever. And thanks all for hanging out and staying with me online. This was fun, and I'm definitely going to be doing this again. Thanks all. Have a good one.